Hello, welcome to another stream. How about that? How about that? But you didn't expect that shit to happen yet again. Hello everyone. Hello Sintus, hello Mr. Botka, Mustafa, Hertz and Plots, apparently potatoes, Aguduk, Sasa, Lala, Go on the third, Aguduk, Out9, Epilepsy, Mustafa, hello, Yatanasov, welcome. So, yeah, today is Monday, if I'm not mistaken, and that means today, according to the schedule, we are programming a virtual machine in C. That's fucking amazing, I think. I do believe so. So yeah, you can find the source code here, and let's just jump into it, I suppose. Just a second, my tea is ready. Just a second. Yeah, professional streamer, by the way. Hello. Start the stream live, yes, exactly. That's how we roll. So, the project is kind of weird, because it's a virtual machine with its own bytecode, and of course, with its own assembly. Right, and the virtual machine is pretty much, I wouldn't say feature complete, but instruction set is pretty much stabilized. So Ramon, what's up, hello. Yeah, so primarily we're working majority of the time on the assembly of the virtual machine, and it's kind of interesting. So the assembly becomes more and more mature, and it actually has a lot of interesting features that I keep exploring by implementing the assembly. So this is probably what we're going to continue doing today. We're going to continue play with the assembly. We'll see how it goes. Alrighty, so let me open the browser. Let me go to the BM. And also let me go to the BM in here, and I'm gonna try to fetch the latest changes. So I have a branch in here, 178, and I have some testing code. Let me clean everything just in case, and switch to the master and fetch the latest changes. That's right. Origin. I don't think I need to fetch the master. Something like that. Okay, the branch has been merged. Merge origin master. And I need to remove the branch. Okay, so everything seems to be okay. Now let me try to rebuild. Oh shit, I also yeah, I have a build system in C, and by doing git clean I also removed the build system itself. So I need to rebuild first the build system. Right, I'm rebuilding first the build system, and then I'm using the build system to build everything else. Yes, I still need to finish my build system, to be fair. Yeah, I basically stopped at rewriting everything from scratch, and I almost finished it. I just need to make the pipes work on Windows, and yeah, the build system is going to be pretty much feature complete. But you need to time and motivation to do so. Maybe I'm gonna do that on one of the streams. Who knows? Maybe that's worth streaming. Cheers, by the way. So yeah. So I also want to run the tests just to see if I didn't break anything. And everything seems to be okay. So essentially, let's take a look at some of the demos. We have some examples in virtual machine assembly. So this is how it's currently looking like, right? So this is the assembly of the machine. And you can turn it into a bytecode, and then using the toolchain you can execute it. So let's actually quickly execute it. I'm going to use virtual machine emulator, and I'm going to provide the build example. And there we go, it generated Fibonacci sequence, which is pretty cool. So yesterday we were working on a pretty interesting feature. We were working on compile time expressions. So essentially now you at compile time you can define bindings and also depend on other bindings and have like mathematical expressions, and all these mathematical expressions will be calculated at translation time or compile time or whatnot, and then will be automatically baked into the binary. So essentially this will be computed at compile time into 6, and it will permanently become the operand of the push instruction. So essentially pushing 6 at that particular instruction all the time. So it will allow you to have like mathematical operations when you computing like offsets in memory and something like that. Did I say 3? I meant 6. I'm sorry if I said 3, so it has to be 6. So yeah, today we're gonna continue working on that, and we have a bunch of pull requests to the virtual machine. Let me take a look at them. So recently Nico implemented the resetting of the debugger and reloading the program. So yeah, on top of that, like we have a pretty not pretty big, but a pretty featureful tool set that consists of different interesting tools. Right, so we have assembly, then we have a debugger, emulator, behavior recorder, did assembly, then a translator from BOSM to NASM, and so on and so forth. So yeah, and Nico recently implemented a feature for the debugger to reset the state of the debugger and reload the program. So I want to look into the implementation of this thing. So before we go into that, I need to pour a cup of tea because I need the caffeine for this kind of stuff. I really need the caffeine. It's really strange. I think my how is it called? French press is broken. How everyone is doing? How everyone is doing? Cheers. I need more tea. So, first, let's try to understand what the fuck is the problem. Right, what the fuck is the problem? Essentially, you have a debugger and you run the program within the debugger, right? So, and where is it located? So, for example, Fibonacci, right? Like this. You can break on main, then you can execute things, right? And then you can step through the debugger like so. You can take a look at the stack. I think stack is this, and then you can continue. And execution basically halts, and you cannot start this program again because if you start it, it keeps halting because it doesn't reset its own state, and it's not really convenient. So it forces you to essentially quit the debugger and then run it again. So it's kind of convenient. Right, it's kind of inconvenient, that's what I mean. Right, so this is basically what Nico implemented. So it's a bit more difficult than anticipated. The issue is breakpoints. See my notes in the code. As I mentioned, there is a certain complexity reloading the breakpoints. As I mentioned, the actual algorithm, it wasn't as complex as it appeared to be. You have any issues? Okay, so let's take a look at this stuff. So luckily this thing is not as big. We don't want to remove breakpoints that the user may have already set, so what we have to do here is to find all of the labels of previously set breakpoints and store those somewhere. Then we can safely zero out the BDB state and reload the program. Now possibly shifted labels can be used as a breakpoints again by searching through possibly shift, so it doesn't even repair the shift. I see. Store the points to the old arena, we lose access to them when we do call BDB. Right off the bat, I don't like that. Copying arena and internals of the arena is a really like against the whole point of Arena. Like, it's kind of against the whole point of Arena. Arena is supposed to simplify memory management, not to make it more difficult. Can we come up with a better solution than just doing these shenanigans? Like, what the hell is going on with... excuse me? Why do we even need to copy Arena? Wait a second. Like, what the hell is going on? I'm so confused. So I didn't introduce arenas to make more trouble for the people like copying it into like backlog and bringing it back. Like, why would I introduce it if I wanted people to use arena like that? I didn't do that for that. No. It actually was the opposite. Okay, let me take a look at what is going on. This is really, really fishy. Okay, so no. This is not the way to go. If this is this for the sake of just being able to zero out? Well, then we need to question, why are we zeroing out? Why are we zeroing out? Are we zeroing out just for the sake of zeroing out? Well, maybe let's not zero out then, right? If zeroing out introduces so much problem of actually, you know, messing up with internals of the arena and copying things around, let's just not do that then. Like, I mean, come on, it's just more trouble and actually error prone. So we need to like look into what the hell is going on. No, this is not the way to go. All right, so let me fetch everything from all of the remotes, and I'm gonna look into the codes. All right, so what's the 88? All right, so 88, and so what we're trying to reset, we have old labels. Where do we even store the labels? Where do we even store the labels? BDB. So label is just this string in here. Old arena, old breakpoints. So basically, the labels are located in a sim file, right? The labels are located in a sim file. Where is the sim file? Right here. So, and essentially, we use the same arena to load sim file and everything else, right? And that's why we have to retain it. Here is an interesting thing. What if we have separate arena for sim files and everything else? It's kind of the point of the arena, actually. So essentially, you have obviously a situation or different lifetimes, right? So you have a lifetime of your breakpoints and labels. They have bigger lifetime than the program. This is literally the definition of the problem. Like the lifetime of your labels is bigger than the lifetime of everything else, right? And the point of arenas is to separate the lifetimes of different objects, right? So essentially you have objects of different lifetimes and you store them literally in different arenas all the time. That's kind of like the point of the whole mechanism. So yeah, if you have a longer lifetime, like for symbols, for everything in the symbols, you store it there. And for things that can get reloaded, you have a different lifetime, basically shorter lifetime. All right, does it make sense? So, and that way you never need to like store and like, you know, stash some like different arena stuff like and everything. You just separate lifetimes. You just have the separate regions for different lifetimes of the object, and they sort of live independently and can be happy with all of that. That may require like reorganizing the code, but at least it's not gonna, you know, do all of. It's not gonna require doing all this weird stuff. Like, all right, so. Okay, this is a go-to. So I need more tea actually, just to be able to refactor all this. Valentin, hello, hello. So let's go to BDB init, and I'm gonna just try to do that. BDB state init, and what we're doing here, we're taking executable that we need to load into the state. We load program from a file. As far as I know, loading doesn't require any memory allocations and standard native stuff. Okay. Okay, then there comes labels. Oh, it's actually separate. And then you load the sim table. And you already... Okay, here's an interesting thing. Where do we use the arena? Where do we use the arena? So let me actually go there. So here is the arena. Okay, here's one. So what's interesting is that we need this kind of stuff only when we're loading a sim table. So here's a slurp in the file. Is there any other place? And here comes this, like, you know, cleaning up the arena. I see. Here is the interesting thing. So you also initializing this stuff, right? You initializing that reloads the stuff, and then you go through the old breakpoints, and you basically set them back. All right. That makes sense. So essentially, I wanna now rename the arena to something else to indicate that it's it has a very specific lifetime. So let's call it sim arena. Sim arena. Okay. All right. So here is the sim arena. So everything related to symbols should be stored there. As you can see, that's exactly what we're doing here. So sim arena. And then we free in, and yeah, okay, so free in the arena is actually pretty good in here. Sim arena, there we go. Okay, cool. BDB init, where is the init function? Okay. So now what I want to do is, so I do concatenation, so this is executable and sim, and I think this kind of executable has to be done from inside. But maybe it could be left like that. So the main problem with init is because it has this step of loading the sim table as part of the initialization, which might not be particularly a great idea. So resetting everything. So you do init. So in the init, right? So where is the second init? Wait. Oh, here's the second init. Funny enough, in the main, when you do the first init, you also remember you were setting BM to hold. But you're not setting BM to hold the second time after you do that. State BM hold. You're only setting it once. Which is kind of strange. Like, why do you do that? Because it's already hold and everything. Okay, so yeah, I see what you're doing here. So now the arena is 100% is used only for symbols. If we separate this step of labels in initialization, so you load program, load the standard natives. What's funny is that you probably don't need to store the natives. We need to get rid completely of this function. Like, just completely get rid of it. Because you need to be able to call all of these functions separately all the time. This is not a very useful function. So we also have this thing, which is a program name. Why do you need this function? I mean this field? It doesn't really look very useful to me. Doesn't look very useful to me. This is major overcomplication, seriously. So we need to get rid of the BDB init. I don't understand why you need here, so I'm gonna straight up remove it. So then I'm gonna be taking out this entire thing and do BDB state init. So the compilation will tell me why you needed this file, and we'll see if it's actually needed. So, alright, so we have that. Then state is a pointer. Oh, goddammit, I keep thinking that it's a main. Alright, so where's the main? BDB init. BDB state init. Alright, so here we go. So here we define state, then we set the state of the BM to the hold, and we're loading all of the native functions into it. On top of that, we're loading the program, right? And the program is argv in here, right? So argv, so I'm gonna put this thing here. And as the last step, we're loading the symbols. So this is a separate step. So these should be separate steps because these functions create objects of different lifetimes. So that's why this thing should be called once, and these things, well, this also should be called once, but this thing should be called when you want to reload something, right? When you want to reload something. Okay, so you provide the state, and state has to be a pointer. Then we provide this stuff, and everything looks okay. So here's the executable, and so I think I know why you needed that could name, but I'm not quite sure why could name is string view though. So because you quite often use it in a context where it is not a string view. So it would be actually, so initially it was actually called program name. So you call the same entity with 3 different names. You call them executable, program name, and CUD file name. So these 3 names, you call them the same thing. So okay, so let's actually settle on a single name for this kind of thing. Like, let's call it a program, and it's in fact file path, right? It's a file path. Quite often, you store it, from what I can see so far. I don't know, we'll see. You store it just to be able to print it, right? You don't use it for anything else except printing, and okay, and also loading, right? Okay, I see why would you, okay, so it's also needed for loading because then you provide it there. Okay, makes sense. Okay, this one is interesting. So yeah, it's just better to like keep the naming consistent across function calls, right? If you pass the same entity across several functions, it's better to call it across several functions the same way, unless these functions are more general. Okay, so there's always but and unless, and yeah, okay, so I should not come up with a general rule. All right. So here is the standard native function. We load that, we load the program, we load the symbols, and we're good to go. So now, on top of that, yeah, so you provide the usage, and here is the state. And for the state, I think it maybe makes sense to call it program file path, and it's going to be sv from sister arg v, right? And quite often, yeah, we don't need to initialize state ever again. Initialization of the state is gone, forget about it. It's not the thing we want to do. So sister concat, so that requires, so this one should be sv concat in that case. Lembakot, what's up? So we sv from sister, then here is that, and then we use state program file path. So state program file path, and this thing should be something like sv from sister, there we go. So this is a little bit, am I going crazy? Wait a second. Oh yeah, I'm not going crazy because it was what I think it was. Okay. So then it's gonna be a state program file path, and this is gonna be sv from sister, So I just want to slightly like split it so it's easier to read. Okay, and we'll load the symbol tables. Cool. We'll load the symbol tables. Ooh. Now, reset. Speaking of reset, I literally don't understand what it's all about. I'm removing it straight up. initialize the debugger. So yeah, if doing this kind of thing, if zeroing out the state requires so much work of recovering the state, maybe you just remove too much state. Let's not do that then. Like, let's just not do that. So essentially, what do we have in the state of the debugger? BDB, right? So we have breakpoints, labels, constants. Do we even use them for anything? Native labels. I guess we do use them for something. Is in step over mode. Okay. People, calm down. We're fixing the code. Stop attacking Nico, alright? He's so far have done more than you for the project. So, yeah. Person who just does nothing and shitposts in the chat versus person who actually does things and not afraid to submit a pull request to the Tsojing project. How about that? So, let's continue. So resetting the state. So when we zeroing out, so what else? What actually gives us? So we have these things. Restore the labels, the breakpoints. So I suppose we can zero out only specific things. It may create problems in the future. It may, but it already creates the problems right now as it is. It already creates the problem right now as it is. So yeah, essentially I just don't want to be able to do that. Just like, don't want to do that. Seriously. And also freeing the arena as an intermediate step. No. This is another red flag. Complete no. The arenas should be freed at the end of the program. Yes, they are created to be freed at the end of the program. In the middle of the program, they could be cleaned. They could be cleaned, basically removed, like all of the pages set to 0, so you can reuse the memory. What's the point of the arena if you cannot reuse the memory? Right? So you create this arena, it allocates more memory, and then later you can reuse that memory again. Freeing it should be at the end of the program, otherwise why the fuck we introduce arena? Yes, like there's no point introducing. Again, I didn't introduce arena to make the life of developers harder. I didn't do that. I'm not that much of an asshole. I am an asshole, but I'm not that much of an asshole. Okay? So arenas are not meant for you to do this kind of shit. No, they're no. You shouldn't do that. Like that's kind of the point. Okay, so let's try to see what we can do here. Reinitialize the debugger. So reinitialization should be as simple, in my opinion, in my personal opinion, reinitialization should be as simple as just recalling load program. Load program from file. In my opinion, I think it should be as simple as that. And we can probably just do it like this. BM load program from file. Yeah, and unfortunately, okay, it requires this kind of thing. So, and I should use state program file path. In my opinion, it should be as simple as that. Plus setting some of these things to null and whatnot. Maybe we can just zero out these things. But yeah, I'm not sure about these things, but I can try to do that. Sure. state that, and just 0, 0. I'm not sure if it's there needed that much, but yeah. And again, so here is the policy. We introduced sim arena, and the policy is you only allocate memory in that arena related to sim files. Everything related to sim files should be allocated there and nowhere else. That way, when you reload things, you don't reload sim files, you don't reload labels because they depend on this arena that lives longer, the arena lives longer than the BM. The BM's life is shorter than the life of the arena. If you need a longer lifetime arenas, you create more arenas in here. More arenas. Arena for maybe there gonna be a temporary arena. But now, if you reload the program and labels shift, everything is going to be broken. But isn't what your comment said initially? So we don't remove breakpoints to previously set breakpoint. Now possibly shifted labels can be used as breakpoints again. Possibly shifted. Well, isn't that what you said initially? Isn't how you could already act? You restore them accordingly. So that means you also reload the symbols, right? Does that mean that you also reload the symbols? You reload also the symbol files. Well, that means it's even easier! It means it's even easier! God fucking damn it! Oh my god. So you just clean the arena and reload the symbols again, don't you? Don't you? I don't know. Wait a second. But you lose the breakpoints. I don't understand. Okay, so let's take a look. So this is the set breakpoints, and what is your breakpoint? Because the address is shifted. I need to completely understand the context of this problem now. I was hoping to work on something else, but now I need to completely understand the context of what you're doing. Otherwise, because I'm completely against of this shenanigans with the arena of freeing it, storing intermediate state of it and stuff like that. No. This is not how you should use arena. And if I knew that people will start using arena like that, I would never fucking introduce it, because why the fuck? So yeah, now I need to completely understand the context and maybe come up with a solution from scratch. So yeah, you're forcing me to come up with a solution from scratch. All right. So that's completely fucking wrong. Let me see. So I'm gonna go back and no, don't be sorry. Maybe I didn't communicate how to use arenas properly, but I really recommend you to actually read region-based memory allocation, memory management, and specifically the original paper, not just Wikipedia page, okay? Not just Wikipedia page, but the original, the paper where it explains how it works and how it's reused and where it's usually used and stuff like that. All right. We need to understand what is a breakpoint. Breakpoint is enabled. All right, whether it's enabled, then ID, and broken is, that means the one that we're broke at. Okay. The ID is completely unclear what it is. I don't know what is ID. So let's see what is ID. Do you even use it? Do you understand correctly? Do I understand correctly that if I just straight up remove this entire thing, it's not gonna change anything? Or am I rebuilding something? Am I crazy? Wait a second. Am I crazy? Because I also renamed accidentally. Okay. Just a second. Is enabled and is broken. Okay, sure. Binding constant. Is this thing used anywhere? Mm-hmm. Mm-hmm. What is constant? What is constant? Any const of any kind. It's any const of any kind. They're not called consts. They're called bindings. And const is a kind of a binding. So, yeah. What you're referring to... Okay. By the way, don't be really harsh on yourself. It's the problem is me with like I communicated that not really well, and don't think that I'm being angry or anything like that. I'm just being very anxious and very disappointed at myself for not communicating that properly. So it's not about you or anything. So yeah, people always take me completely incorrectly, thinking that I'm bashing on people. No, I'm actually bashing on myself, thinking that I didn't communicate it correctly. So at the top of the hierarchy is a binding. Const is a kind of a binding. Then another kind of a binding is a label. And another kind of a binding is a native. In your case, you put const here. Const is not a generic thing. It's a kind of a binding. The general term for these entire things are bindings, right? And that's why when I look at the array of constants, I'm thinking, why do you need constants in a debugger? You only should be interested in... And why do you use constants in such a generic way? It just doesn't make any sense to me. All right, so... So it just makes it difficult to explore for me. So binding constant. So in binding constant, that means binding. You mean binding, right? So you just mean binding. Cool. And if it's a binding, right? If it's a binding, it should be something like that. So this is bindings, size. Do I understand everything correctly now? Do I understand everything correctly? So it's just any kind of bindings. I think Nico left. So I'm sorry, Nico, I scared you away. Why am I such a horrible person? Like, what? Okay. Alright, so... yeah. The question now... why do we separate these things? All right, so we have native labels. And we just have labels. And BDBC, label or address. Parse label or address. Yeah. Parse label or address, you then check. You literally re-implementing something that we have in Bosom. Like, this is literally what we already have in Bosom. Okay. I'm gonna take a look into that pull request after the stream. This pull request requires like a lot of thorough analysis, and also I need to research what exactly you're doing, because you're doing something really strange in BDB that has nothing to do with how virtual machine works. And the reason why you do that is because I didn't document anything really well, and now. Alright, let's make a small break. I'm very disappointed in myself. Like, I should have started documenting everything, but I haven't finished the design of the virtual machine yet. Yo, what's up? Welcome back. Let's continue. I still want to finish this pull request. Forgot the name. Okay, here's the name. Let's start with the bottom line of making things simpler. All right, so lookup times are very cool, but do we have any actual performance concerns right now? especially when I'm not even sure if I'm gonna have the kinds of bindings that we have right now. Right, so right now we have a system of bindings where you have a constants, native, and so on and so forth. Believe it or not, I'm planning to get rid of that in the future as well. So, because again, I'm in the middle of the design phase and I'm thinking to get rid of that too. So yeah, in the plans we're not gonna have that. And what's the point of thinking about lookup times when this thing is gonna be illuminated completely? Let's start with making things simpler. Right, okay, so first of all, this is that, and this is a binding. This is a BDB binding, and a binding in BASM, right, can be different kinds. So we literally have a binding kind, right? So, and what's funny is that we are repeating a structure called binding. So we have kind, name, value. You don't have only file location. And the question is, do you even need file location? Probably not. So probably not. So let me see. Let me actually put them in the same order. Ragul, thank you so much for 6 months. Is it really that loud? Okay, I'm gonna actually put it away. I don't know what the fuck is going on. Is it better now? Holy shit, that's really strange. I don't know what is going on. It's kind of weird. I really need to focus. Okay, let's make this thing simpler. Look how simple it is. Isn't that beautiful? Program name. So we have the state of the machine, the file name, the breakpoints, the the bindings themselves. No, not the constants, by the way. Not the constant. They're not the constants. Const is the kind of a binding that you probably don't care in the debugger. They are bindings. They're bindings. And also different modes. Okay. Now that makes perfect sense to me, because every time I was looking at the structure I was thinking, what the hell is going on here? Okay, so that makes perfect sense. Breakpoints, different bindings, different modes, cool. And especially we have a sim arena. Okay, finally this starts to make sense to me. Like, okay, I do understand that lookup times is a cool thing, but let's just keep things simple, right? Yeah. So, and another interesting thing, like that I constantly see in your code, I do realize that it's a stylistic thing, right? I do realize it's a stylistic thing, returning these errors, but all of these errors end up in a crash in application. And to facilitate propagating those errors from the bottom of the stack up until the point where we crash creates so much code noise that I'm thinking, is it really worth it? If an error happens and you wanna crash, can we just crash then? Like, and it will reduce all of this noise of checking, returning, checking, returning, checking, returning. Like, all of that is gonna end up crashing application anyway. So, not all of that, but majority of that, and it just makes it really difficult to like go through this syntactical, like not syntactical noise, but like generally noise, like you see what I mean? So I usually like this is cool for recovering from the errors. I do realize that this is cool for recovering the errors, but when you don't need to recover from the errors, why to have that mechanism in the first place? So this is basically, I think I already talked about it. Essentially, I don't try to introduce these error recovery mechanisms into the code until I actually need it. So when I'm only starting the program to write the program, if an error happens and I don't know what to do with that error and not a single part of the code knows to do with that error, I just crash. I always just crash, and it especially works well with batch programs. I'm talking about batch programs. I'm not talking about web services or 24/7 applications or anything like that. Okay, so they have different kind of forms of handling errors, and even then we have a situation like Erlang where it is okay to crash because you have supervisors that recover you, whatever. So essentially, and then only when I need to recover from that error, only then I introduce a mechanism to recover from it and return a boolean and whatnot. And so I only introduce this noise in places where it's actually needed, where I know that yes, I need to recover from that error. So for the longest time, for example, slurp in the file, slurp file, was just crashing if the file doesn't exist. It was just crashing, and it worked fine for a very long period of time until we needed to do something special when you're trying to include a file, and we don't need to crash, we need to gather more information before we can crash. And only then, okay, I introduce this int in here, I introduce like return of the content via the argument, okay, and I knew that it was justified. Right, I didn't introduce this noise before it was actually needed, and that simplified the code dramatically, at least for me. I don't know, readability is a very subjective thing, but I just wanted to, you know, mention that. So, yeah, anyway. All right. So let's try to do what? So for example, here you don't need to crash, okay, and I completely understand that. But in that case, you don't return BDB error anyway. So, okay, let's do it. No build. Okay, initializing the state. Alright, so it's going to be program file path. So this is the executable. So you set it to Sister. What's funny is that for the program file path, we accept sister in here. So maybe the program file path has to be sister. I think it should be sister. Like, I'm still contemplating whether I want to make it a sister or not, but I think it should be a sister. So program file path, and we assign program file path in here. And then we load the program file path, and then we can create sim file path. Should be something like this. I wanna move this allocation inside of the BDB load sim tab, and if I manage to move that allocation inside of that function, all of the allocations related to sim table will be inside of that function. They will be inside of it. All right. So in that case, it should be just program file path. And I think this is, I was who actually like separated this entire stuff because I didn't expect how it's gonna turn out. So yeah, so I'm basically refactoring all of that back. Program file path. Alright, so that means I can move this thing here, and this is a program file path. Load sim tab. And also another interesting thing, I used to do these kind of assertions myself all the time. But then I realized, like, if you don't have this assertion, right, it's gonna crash anyway because you're dereferencing this thing. But maybe, okay, so whatever, we can keep the assertion. Yeah, so in that case, it's whatever. It just doesn't matter. I don't know why I'm talking about it. I'm sorry. Okay, so it's gonna be the arena. Then I take a program file path, and then this one is gonna be string view sim tab file. Okay, cool. Nice. So now everything, all of the allocations related to sim table, they are located inside of that function. Cool. What's interesting now? Breakpoints, right? So let's continue compiling and see where we're gonna where it's gonna hit us. Sure. Did I name it slightly differently? bdb.h file path. Sure. Okay, so program file path did not work because this entire thing was, yeah, it's also defined in header. So it's going to const char program file path program file path. Of course, I actually made this thing here. I'm mistaken here. All right, so find address or a label. Find address or label. You know what you're doing essentially? You're re-implementing the thing that we had here. Bosom resolve binding. So yeah. What's interesting? So what does it give you? Instruction address. So, and I wonder how much code you can share between Bosom and assembly. So, and the way I did that is actually super simple. You have binding as a slot that contains all of the necessary information, right? And you just query it, right? And it gives you the pointer to that binding, to like a copy of that binding actually. And you can just do whatever you want with it. Like you can then look at its type, if it's the right type you want, and so on and so forth. So it would be kind of cool to also have that, like the whole binding, because you're not only gonna have the address, you're gonna have everything associated with it, right? And yeah, so let's actually port this function to BDB as well, because why not? I think it's a pretty useful function. So in that case, you accept BDB state, and this is going to be BDB. You accept the name, and you return BDB binding, right? And I still want to separate them because Bosom binding, right? Bosom binding, it also contains file location, and file location is within the source code, which might be useful for the debugger, by the way, in the future. So I don't know, we'll see. But you don't have anywhere to store that, right? So yeah, okay. So this one is going to be BDB resolve binding, and okay, in the spirit of BDB, let's return BDB error. Sure, I don't mind that. And this one could be BDB okay, right? And this one could be BDB fail, BDB fail. Right, and we can also check the assertion of BDB, and we don't have to check the assertion of out. You know why? Yeah, this is actually, yeah, in my opinion, this kind of code is rude. This is straight up rude, in my opinion. You know why? What if the user of this function doesn't care about the value, but they just care whether the value exists or not? You force them to create a variable on the stack provide the pointer, and then just throw that variable away. Just allow the user to put null in there, right? Like I did. So you see, I check, is it null? If it's not null, only then I provide. If it's null, I don't provide anything, I just say it does exist. So you see, it makes it a little bit like easier to use this function, like it in more cases, right? And I learned that by using SDL a lot, by the way. Because SDL has a lot of functions where they also don't allow you to do this kind of shit, right? And sometimes I just don't care, just let me do that. But it also has functions that sometimes they do allow you to do that, and it's just kind of like, So yeah, I think it's pretty like good style to allow users to just ignore the value, but also check the presence of that value. All right, so this, and I think we can say that this function will be used instead of that one. And in a place where you call this function, you will simply check the kind of the binding, and if it's a label, you're gonna do one thing. If it's a const, you're gonna do another thing. If it's a native, you're gonna do the third thing, right? So, and that way you don't need to have like too many functions or anything. So yeah, I'm talking too much, I'm really sorry. So what was that? Find and resolve. After the stream, nobody's ever gonna submit pull requests to me. Holy shit, I'm such a horrible person by myself. I should just write more documentation, but the problem is that I'm afraid to write a lot of documentation for this thing right now because it's changing too much. Is it possible to have labels in Boson that has the same name as constant? No, it's impossible. That's kind of the point. Yes. Because they're all bindings. It's just like, it's impossible to have a variable int x and float x, right? Just because they're different types, you still cannot create them because they're names in the same namespace. So that's what they are, essentially. And this is basically the hint on why I want to get rid of the binding kind system, because I'm going to introduce type of the expression system, right? So it's going to be a different thing. I'm not even sure if it's going to work out really well, but yeah. So because essentially the kinds of the bindings is like a type system pretty much. Oh, okay. I really apologize that I don't document anything. This entire situation is actually completely my fault. It's not your fault or anything. You're a really cool programmer. You're a really smart programmer. I'm dumb because I don't communicate well. I don't document really well, and I'm also get really irritated because of that. So I'm mad, but I'm mad at myself. Like you did actually your best. So I'm really sorry about that. I'm really frustrated, but because of myself. So yeah. Yeah. I wish I could be better open source developer, I guess. I don't know what's the role I am, what's the role I'm playing. Because yeah, as the leader of the project, I'm supposed to be responsible for making it easier for people to get into the project, and I'm really bad at it. Holy shit, I'm really bad at open source development. I'm really sorry. Because like, again, I'm afraid to document it because it's probably going to be changed, but maybe I shouldn't be afraid of that. It's just a lot of things to document. I kind of wanted to document that after the whole idea has established, because there's a lot of unestablished things here, so which I'm not really sure about. Anyway, So let's remove this entire thing. Okay, so resolve binding, and let's recompile one more time and take a look at what's going on. What do we have here? So it's not a boson. Oh yeah, I should know. Query replace boson with VDB. Write an architecture. Yikes! Fucking yikes. Imagine just quoting like a top upvoted post from Reddit instead of your own thoughts. That's a major fucking yikes. Holy shit. Hello, Carrot91, welcome to the stream. So... Maybe like an influencer, probably there's no point in documenting anything what's happening. Good code documents itself. Not really. Lobsters leaking into the... Where was it posted first? First I saw that on Reddit, I think. To be fair, I don't read anything except Reddit these days. It's kind of weird. So my daily routine is to go to Reddit programming, scroll for a couple of minutes, get a cringe stroke, and just close it. That's my routine every day, and it's just, yeah. I only read Lobsters, so maybe that's why. Oh, okay. So like three major like platforms: so programming subreddit, Lobsters, and Hacker News. I think they pretty much duplicate each other. So so there's no point in reading all of them. So you can just pick one, and yeah, it's the same shit. So cringe stroke. Yeah, it's every time I read one of these resources, but they're so addictive. You cannot just stop reading them because you're always like, you have a fear of missing out, you know. And yeah, I go to /g every day, get meme stroke, close it, and do something else. I see. Alright, so let me see what we can do here. This one is called Sim Arena, right? So, Sim Arena. Okay, so here's the interesting part. Load sim table. And you know what's cool now? Since we smashed all of them into a single thing, we can pretty much remove this entire stuff, I think. So here's the chop by delimiter, you have kind, and essentially you can do state bindings, state bindings size, right? And what we do here is the name, label name. Then what else do we have here? Value, and kind. And you know what? So there's kind of like a asymmetry here. Value, kind, name, name. Okay, so name. And there is even more interesting thing. Why don't we just inline them then? And by the way, so I think this can be removed now. Okay, so that makes sense. So this eliminates the whole class of the problems, which is nice. So and after that, maybe I'm not going to inline it. I think inlining it is going to make it kind of difficult. According to my calculation, it was first posted on Reddit. Oh, okay, that's cool. So, what were your calculations? You looked at the date? Interesting. Data analysis. Cool. Actual data scientist. Useless Pony, hello. Welcome to the stream. So what do we get? What do we get? What do we get? What's that? Ooh. Okay, print instruction. So you have an instruction. So we have. So if it's instruction native. Native labels. I see what you mean here. Oh, it's now I understand why you need them. All right. So native labels. All right. So we need a function that will query them by name. Wait. By address or by value? Okay. So I want to make a cup of tea. Why it became so popular, this, you know, this architecture thing? Oh, I know! I know why. I literally know why. So essentially, there's a lot of talk about open source and contributed to open source, but it's so hard. And people who want to get into the open source, they don't really know how to go into the open source. And I keep thinking about the reasons. Why can I go into the open source? Why can I become the epic open source developer? And the article provided an easy answer for them. Yeah, it's not your fault that you cannot read other code. No, it's the fault of the project. They just didn't have an architecture.md, and that's why you cannot become an epic open source contributor. Dap. So it's their fault. Yeah, it's literally that. Shifting the blame. This is a perfect recipe for becoming viral. So you provide them a way to actually shift the blame to something else, and it become so fucking popular. Right? It's the project's fault. Which quite often it is, but it's not as simple as that, actually. It's actually more complicated, in my opinion. It doesn't add up. Or doesn't add up? Or you about the dates? Something. So, it's quite often... Yeah, the situation is kind of quite complicated. So everything has to line up. Everything has to line up. Your skills have to line up. The level of documentation of the project have to line up. So the people within the project also have to line up. It's a very complicated situation, right? And it's not as easy as adding like architecture.md to the project. So yeah. But it's just boiled down to just simply add that file and suddenly like it's gonna be super easy. But then you can argue that architecture.md could be the first step into improving the situation. Yes, it could be. All right. So native labels. Querying by address. Actually, this is kind of interesting. So this kind of mechanism doesn't really work easily anymore. No, why? Anabotha, what's up? I'm gonna show you something cool. So this is a flawed idea in my opinion, generally. Let's create a simple program. So you have something like function foo, and yeah, let's just create a function foo that returns. Then you have a main, because X11 is busy in architecture. So is architecture.md becoming the new borrow checker? I think it is. Oh shit. An epic misunderstanding happening in the open source project. Architecture.md would have fucking solved it. Oh boy, we're up to a pretty great shitstorm. Oh, I love it. Holy shit, yes, that's what we need in our lives. Okay, so, yeah. Now I understand what you were trying to do, Nico. So, but here is an interesting thing. What the fuck is architecture.md? It's a new meme. It's a new Reddit meme. This is the file that you have to put into your project along with license, readme, contribution MD, and you also need to have architecture MD. And if you don't, you're a fucking disgrace of open source community. Get out of here. Yes. So, or something like that. I don't know. So, oh shit, I need to make a cup of tea. Back in my days, it was called hacking and documenting the code as it stood 2 years ago, if you were lucky. Yes. Back in my days. Sorry. Alright. Which is actually true, by the way. I think it was called hacking, and it's still in old projects called hacking. Yeah. And hacking was, I think, basically like a combination between contributing.md and architecture.md, so it's basically smashed together, which explains like how to get into the project, right? So yeah. Okay. Let's readme first. Yeah. Alright, so here's the thing. I think I need to compile this stuff first, and it's gonna be Basm. Test Basm. Output test bm, and let's do bdb. Let's do bdb. No, this is not how we do that. Bm bdb. I forgot minus g. Yes. There we go. So then I can break on the main. Then I can run this entire thing. And next. Okay, so I have to do push then. What's going on? Okay. Basm, bdb, break main, run, and next, call foo. Cool. Now, this is a valid Basm. see what I mean? You see what I mean? So that's why this entire idea of you know, caching these like values and making a mapping between address and the name is flawed, because we don't have labels as operands anymore, which is, it's not a thing. So you know what would be a better solution? Is to have a mapping from instruction number to the line number, from instruction to file address, and act like GDB. Essentially, you should also parse the source code and map the source code to the current execution and show the actual line from the file. That's what needs to be done for a proper thing. And this is a cool justification for me to just remove all of that. Yeah, you see what I mean? Yeah. Essentially, I'm gonna remove all of that and put it to do for a better, you know, displaying of the instruction, because so yes. Again, all of that is not your fault. Please don't get me wrong or anything. It's just me being bad at communication and open source developer. Yeah, this is because I didn't have architecture.md. That's why. Let's create architecture.md. So architecture.md. So what we're gonna put there? Don't be sorry, it's fine. This is strange. Alright, so what am I doing here? I just stashed something. But was I in a different branch or something? I think I was. Alright. Alright. Now, I'm going back to the 88. Copy paste Rust architecture.md. Oh shit! Did the article said that the content of the architecture, well, it said that the content of the architecture should be related to the project. Can I use somebody else's architecture.md and would it solve all the problems in my projects? It's a pretty good idea, actually. Yeah, I can probably copy paste it. And it needs a little bit more time to extract that sweet caffeine. Alright, so what I was trying to do, let's recompile. Okay. Yes. So print instruction. When we print an instruction, we're gonna just stick to that simply. Do we have a new line anywhere after we print it? I think we don't. I think we do a print line, a new line. Yeah, we do it afterwards, I see. Also has that. Okay, instruction. Alright. Cool. So how am I gonna word it? Print. It actually depends how we use it. So instruction. And another place. All right. BDB print inster should take information from the actual cool. Thank you so much. All right, so BDB state, unused parameter state, which is kind of interesting, but you will need the state in the future, so I'm not going to remove it. you don't forget to remove this when you start using state. Okay. Cool. Labels. All right. Is broken. A label. This is broken. I see. ppm. Breakpoint. So you want to be able to say if it's at a particular label quite easily. Here's the interesting thing you can do instead. Why don't store the label in the breakpoint? About that. Okay, so here's the breakpoint, string u, and this is a label already. This is a straight up label, and it could be null, right? If you broke at something else, right? It could be actually nothing. So it's essentially like, yeah, smashing them together. But here's the thing, break. Add break, right? So you break at a particular address, and if you break at a particular address, what if you break at a label? Right, so you try to parse label or address. You're trying to parse label or address, and basically you don't have enough information with its label or address, and that's why it is the way it is. Alright, so we can try to do that a little bit later then. But I may forget that in the future. So I'm gonna add a to-do. So I can hammer into pasting my nick with the base64 stuff into his terminal after the stream. But I mean, he's using Windows, doesn't he? So does it work on Windows? Or you managed to convince him to do that on Linux? Oh, okay, so he's using Arch, I see. I mean, I'm pretty sure he was using Linux before. He using GVim on Windows. People don't use GVim on Windows out of nowhere. It's like using Emacs on Windows, right? So people who use GVim or Emacs on Windows, they used a lot Linux before in the past. Yeah, that's a huge giveaway. It's like, yeah, and that also gives away John Blow, right? John probably used a lot of Linux in the past. I can fucking tell you, he probably was a, like, you know, Linux hacker for the longest time. So it's true, GVim using, yeah, I told you. I used women's, but it's just an exception. It does not, you know, determine the rule. Yet he uses some kind of win-grep bullshit to do his search and replace. Yeah, I guess. He was actually saying that he used Linux since the beginning. Like, because Linux was released in 1991, right? And he said that he used Linux at the time, like when it only like sort of came out or something. At least he tried this thing. I don't know. He's been doing this kind of shit for a very long time already. I haven't used Linux. I mean, The other way around may not work. Anyway, let's continue programming. Let's continue refactoring. Let's continue refactoring. So, yeah. So far, there's not that many problems with your code, Nico, except like the code looks very uninformed. Basically, if you had more information on what to do, you probably wouldn't written it like that. So yeah, again, sorry, cannot stop apologizing. So hit breakpoint and then the label, and yeah, I'm gonna just remove that. So print label on breaking. Okay, so I'm gonna just temporarily put a to-do in here, and then I will go back to that to-do. Okay, so here's what we do here. Parse label or address. Parse label or address, and this thing should return the actual value, but do you really need to do that? Oh shit, you know what would be even cooler? If you could use bosom expressions in BDB. Yeah, so in that way you could break on 1 + 2 + 3, but I need to actually make it a little bit easier to use. Right now, how you do that? Right, you have parse. Oh, it's in a different branch, yeah. So essentially, I'll try to think about how to introduce that. Also, there's a lot of interesting things, like is essentially you're implementing a lot of things that I already implemented in BM. So the code reusage needs to be done at some point as well. So BDB parse label or address. And what we do here, we're trying to, yeah, essentially all of these mechanisms of trying to parse the value, they're obsolete because now we have expressions and shit, so all of that just doesn't make any sense anymore. Yeah. So BDB should be able to break on bosom expressions. Bosom, the whole bosom expressions. So okay, and then here, what we essentially do, we have to do BDB resolve, BDB.h, resolve binding, resolve binding. So this is a state and address. Because it's well, yeah, it could be address, it could be, yeah, that makes sense. And out in this particular case is gonna be something like BDB binding, right? And we'll just do it like out. Right, and if it succeeds, right, if it succeeds, we just do out binding value. There we go. Only Vim2? Yet another Vim fork? How many of them do we have already? Oh, I think model editing from the, okay. Pre-order. Oh yeah, I remember. I think Out9 actually showed me that. Yeah. Vim Visual Studio Code. Cool. So looks neat. Well, that's a keyword. Looks. Okay, so another thing. Print location. All right, this one is interesting. Print location. So we just need to find the previous label. But do we need to find the previous label? Or do we just need to find the closest label? The closest label that is less or equal to the IP. That's what we need to do. And it's pretty much the same asymptotic as this code, so shouldn't be that difficult. So this particular mapping doesn't really improve anything. $40 for alpha build. Well, that could be part of the marketing. So it's sort of like the creator claims that it's worth it. All right, let me see what we can do here. We can iterate through all of this stuff. I'm iterating through bindings. I'm slowly iterating through bindings. Binding size. And if state bindings I kind is equal binding kind. I think it's called binding label, right? So this is a binding label. So, and what we're printing here, how often do we call this function? Print like, okay, it's a by command. Okay, that makes sense. So, and just thinking how it would be better to do all that. Inst address, sort of like location. So we're gonna call it like a location, but I want to mark it somehow specifically. So if you want to find the closest one that is less, right? And so there's another condition here. And if state bindings I value as U64 less or equal than IP, then this is a potential candidate for all of that. This is a potential candidate, and what we're gonna do here is we want to try the smallest one, and in that case, can we have like a max int 64, actually max u int 64, max u int 64, and essentially if lock is greater than this value, right, we want to set this value to the lock, right, like this. But there's also no indication that we found anything. There's no indication that we found anything. So let's do something like found lock, which is initially false. And because of that, we don't really need to have any of these shenanigans. We can set it to 0, and basically if not found lock or the location is the current found location is greater than what we found so far, we just set it to that and we say found location to true. And yeah, after that, if we found the location, Oh, wait a second, we have to print the label. That means we can use string view label like this. So it's initially begin 0. So instead of found, yeah, if label data equal to null, or location is greater than that, we set it to that, and found lock is set to that. Though again, we could make it even simpler. We could keep track of just I. Yeah, we could keep track of just I, and then we can recover this information from the I. Yeah, and that means we don't really have to do any of this stuff. That's pretty cool. Let's commits does not become open source immediately, but some months later. Open source, not open source. Everything has to be open source. All right. Okay. So I'm thinking I'm gonna just keep track of the index of the binding. Or do I have to do that of the index of the binding? I can actually keep track of the pointer of the binding. BDB binding, and it's initially null, right? So I'm iterating through the bindings, and if let's call location. So it's gonna be a location. And when I'm doing that, I might as well do something like current. Right, so it's going to be current. And interesting enough, I don't plan to modify any of this stuff, so I might as well actually mark them as const. So this is going to be that, and now, instead of doing this thing, I can do current. Right, if the current kind is label and current value is less than IP, that means we found something. And if location is null, or location value is greater than the location that we found in here. So the current, and it's actually this has to be as u64. What we're essentially doing, we're just setting the current to the location. There we go. That's actually how simple it is. Holy shit. So it's just a pointer to the location. And yes, and then if you do have the location, right, then you just use the location name and offset. What is the offset? Do we really need to have an offset? Because we don't compute the offset, right? We know exact value, so we might as well just use location value as u64. Otherwise, no location found. So this is basically how we do that. Right, you see, we iterate through all of the bindings, we find, we only look for the labels that are greater. I think that's a pretty good thing. Test. Because I'm not sure if I did any significant mistakes. I'm not sure if I made any significant mistakes. And speaking of this function, just why? I usually never really, you know, point out any stylistic things, but just why? Like, I pretty much like believe that people should style their code however they want, right? But seriously? I don't know. Yeah, I do understand why you do that. It's a force of a habit, right? So it's a force of a habit. But then it introduces too much noise. But again, readability is very much a subjective thing. But maybe I'm sorry, it just doesn't matter. Like I don't know why I'm bike shading on that. This is literally bike shading. I'm really sorry. Doesn't matter. Okay, so all of that doesn't matter. So it's just stuff. Okay, so and oh yeah, you don't need offset anymore. Yeah, I guess failures beat me in the ass quite often times, so I do it. Yeah, okay, that makes sense. That absolutely makes sense. I can see why would you do that. So. Alright, so parse labels, address, or constants. Okay, so let's actually rename this to parse bindings. I guess single binding? Parse. So first you add that and... Parse label, address, or binding. So first you check that it exists. So where do we use that? Where do we use that? We use that in X. Okay, so this is another case where, I mean, it probably should... So this is for the memory. Oh, and speaking of, so this is out as U64. Wait. Well, you don't need that anymore, right? Since everything in a single place. Yeah, the only reason why you needed that is because yeah, there was a separation between labels, addresses, and constants. Now, yeah, you can just use BDB resolve. You can just do BDB resolve binding and just resolve the binding correspondingly. So, and what's interesting is that, like, I don't know why I say you, because I implemented this. So, I clearly made this. So parse label, address, or constant. And can I just provide the amount? So so label address, and it uses resolves binding. I see. So that means I can straight up remove everything. Okay, that makes sense. I can see now. I can just remove everything. So, alright, this one is interesting. So I really don't want to go into that yet, into the resetting, because it's kind of unfinished, but okay. So if we are... So we are in the middle of resetting and stuff. So... You want to clean everything except breakpoints, and breakpoint you were also trying to adjust breakpoints after reloading. And this is why I had this idea of associating breakpoint with a label if possible, right? With a label if possible, because then we can essentially do that. We can essentially do that. So then you go through all the labels, all the breakpoints, is enable all the data. So if there are labels, all labels equals, okay. And the breakpoints is like the entire thing. I'm just thinking whether this way of storing breakpoints is actually good or not. For this situation, I mean, for what we're trying to achieve here. If we need to constantly adjust them, maybe it would make sense to do something different then. Okay. What if the breakpoints was a list of breakpoints rather, and breakpoints would have something like also an address, instruction and address of this entire thing. And oh yeah, breakpoint could be either an address or a specific label, right? Either an address or a specific label. And once you remove that, so usually here's the interesting thing. You made breakpoints like this for very quick, for O of 1 lookup for like address breakpoint, right? So basically you have O of 1 addressed breakpoint. But the question is, how many breakpoints do you have usually in a single session of debugging? To be fair, if I have more than 2 breakpoints in a single session of debugging, I think I'm doing something very complicated. But I mean, I'm not really a debugger person, so that's the thing. I'm not really a debugger person. So maybe if I went in more deeper into different debugging techniques, maybe I would have hundreds of breakpoints. But even then, iterating over an array of 100 elements is actually not that bad. So what I'm thinking, what if the breakpoints was actually like a list of something like this? So it's not broken. The yeah. So you don't need to have it enabled or anything, right? So we have either label or address, right? If the label null, we're using specific address. Or furthermore, do we even break on specific addresses? Let's actually say you cannot break on any specific addresses, and breakpoint is always a label. That means that you never have to adjust anything. Right? If your breakpoints is just a list of labels, right? If your breakpoints is just a list of labels, you don't really need to adjust anything. Or maybe for a little bit faster lookup, you still want to cache the address of the label so you don't recalculate it. Then the whole adjustment is just iterating through all of your breakpoints and updating the address of the breakpoint. So I think trying to make a mapping O of 1 made the architecture more complicated than it actually needed. If you just kept it as a list of breakpoints, not the mapping address to the breakpoint, it would be easier to implement. And that's exactly what I'm going to do right now. I'm going to refactor it to be just a list of breakpoints, and yeah. So that's what we're going to do. Can you remove breakpoint, by the way? So you can break it. You can... Perfect. That's goddamn perfect, actually. Holy shit. Yes. Yesu kawai desu. So, and I wonder how much stuff I broke while refactoring all of that. What if you have an executable without debug symbols? Yeah, this is exactly, I already addressed that. Basically store address, always store address, and adjusting breakpoint is iterating through the new labels and just updating the address. It's actually easier than whatever's going on here. Is enabled should have better called is set. Yeah, probably. I don't know what it means, but I'm not gonna bring it back. So yeah. And by the way, after I've done all of that, I will need a review from you. So essentially, here's the idea. I'm gonna do this refactoring to my vision and also with my knowledge about the project, and I'm gonna commit that, and then I'm gonna pass it to you so you can review it as well and tell me if I made any significant mistake or broken something very significant. So this is gonna be the idea, right? Because I definitely broke something, I'm pretty sure. I'll try to like minimize the damage as much as possible, but this needs to be done. Basilevs, what the fuck? Hello, haven't seen you in a while. How are you doing? How are you doing? We're programming in C. Am I weird for preferring BDB breakpoint? You're not really weird, to be fair. You're just like 95% of the people bike shading. I would even say it's a norm. Bike shading is a norm. Not bike shading is actually kind of like a weird. Like, why don't you do that? Like, it's majority of people bike shading, so don't worry about it. You're completely normal. So. So what do I want you to do? What do I want you to do? I want you to pee. That's what I want you to do. Why don't you use blue to highlight keywords? I don't know. I am weird like that. Small break. So it's gonna be 3 minutes. Maybe it's gonna be 2 minutes. Yeah, let's actually do 2. I didn't drink that much water for 3 minutes, so I think 2 minutes is gonna be enough. I like my sheds. Alrighty, so let's make a small break, and you guys have. Yo, what's up? What's up? What's up? I have no idea what is zone when idle. So it's basically zone. What about zone? So there's also zone. Zone out completely. Okay. So create a buffer zone. Switch to the buffer. So it also has a special zone. Very funny. Okay. So let's continue. What I was doing? So when I want to reset everything, right, I want to just reinitialize, right, and maybe that's exactly what I'm gonna do, right? So reinitializing is you load program from the file, load standard native functions. Maybe you don't need to like load them yet again, but it depends on what we do here. We actually append them. So here's an interesting point. We actually append them, and we want to reload the table. So let me quickly do the following thing. Load sim table, and when you load in the sim table, what are we doing? We're just appending everything, but we also have a binding size. Okay, that is very much straightforward. Okay. BDB state init. So this is a reset. Okay. So we already have a program file path. That's cool. So load program from a file. When I'm loading for a program from a file, do I do anything special? So I set n, I check the magic number, then I set IP to that, memory size, I set the program size, I always reset all of that. I should also reset the memory size. Okay, so everything gets reset, so it doesn't really care about specific values and whatnot. So different kind of sizes. Different kinds of sizes get reset. Okay. Anabot is back. Back! Champion of the arena. What's up, Anabosu? Hello. Alright, so that's okay. But what about natives? Right, natives. VM. I feel like load program from file should clean the state of the VM completely. Essentially, mem set bm 0 size of bm. Maybe even like bm dereferenced. Right, so I think that's what should happen. So you load this thing, then you can load standard stuff. Then in the state, you take arena, and most importantly, we clean up the arena. Arena clean, which will just reset the sizes of the pages to 0. It just resets the pages to 0. Arena clean. I think it has to be sim arena. Okay, so this is a sim arena. And then if this thing failed, if BDB error, right, we return BDB error right away. Cool, loading debug symbols. So we reset pretty much everything, but before we can reset the symbols, we also have to take the state and do something like, not really bindings, but yeah, bindings actually. bindings size equals 0. Yeah, so we clean arena, we set binding size to 0 and then reload the bindings. And that's it. That gets rid of that gets rid of that is not needed. Reinitialize the debugger. So I probably also need to think of what needs to be cleaned up there. So we don't need to set that, so that is already okay. Breakpoint should be okay. Bindings. Bindings should not be reset. Only this kind of stuff should be probably zeroed out just in case. I'm not 100% sure, but maybe just in case it needs to be zeroed out. So we'll see how it goes. So of course I know that it's kind of dumb, but there's nothing much we can do about it anyway. Alright, as you may have already said, so we have to do here is to find all the labels previously set to the package, store those somewhere. Well, we still need to document that we are adjusting the breakpoints, but not for now. Alright, so we don't need that for sure. And now I think, of course, that is 100% no. This could be simpler, I think. This could be simpler. How simpler could it be? Essentially, if we treat BDB breakpoints slightly differently, so is enables is set. If the so we're gonna have a list of breakpoints that are already set. So if the breakpoint is in that list, we consider it to be set. If it's not in that list, we don't consider it to be set. It's as simple as that. So now we're gonna have a label. Right, we're gonna have a label, and label is probably taken from oh shit, that's actually interesting. Label is probably taken from the symbol table, so that's kind of interesting. Does BDB uses int3? No, it doesn't, because we're not debugging the native application, we're debugging emulated application. We just don't need that. And then we're gonna have instruction address. So this is an address. And here's very strange thing. Maybe we do need a second memory. That's very interesting. What would be the best way to do that? So we want to load new symbols. But we still need to call the previous ones. Okay, so here is another lifetime problem. We definitely don't need that, so I'm gonna just remove it right away. Maybe we could have a second arena. Yeah, so here's the symbol arena, and the second arena is breakpoint arena, which also stores the name of the labels in a second arena. Right, that's where it's gonna store them. So arena, break arena. I'm not sure if it's a good solution generally, but we'll see how it goes. I need to make a cup of tea. Does anyone have any questions while I'm making a cup of tea? We can have a second arena specifically for the breakpoints. Yeah. Second arena specifically for breakpoints. Chat, why are you dead? Why are you dead? Is that because I'm struggling? Yeah, probably why. Probably why. Don't be dead. I'm not dead. Sure. I'm just searching how to kill a patient. Fuck. Okay. Alright, so we're gonna have a break arena for the breakpoints. Right. Break arena for the breakpoints. Yep, clock. So we load the symbols, right? We load the symbols. And what's funny is that what if the labels are not available anymore? How's maintaining build health going? It's going okay. You just shave it from like once in a while, and yeah, actually once per 2 days. And yeah. So let me lurk. Well, I mean, sure, keep lurking. You don't have to answer my questions actually. Did you know that if when I ask why are you dead, you don't have to answer anything? Like you're not obligated, like in any way. So, all right. So let me see. We're gonna assume that the labels, and it's quite important, labels of the breakpoint are located in the break arena, not in a sim arena. That's kind of cool. That's kind of cool. So that means after that I'm iterating through all of the breaks, and of course, yeah, you're gonna have size t, breakpoints size, right? So because now we interpret it completely differently. So this is size 0 less than state breakpoints size plus I, right? So if state breakpoints I label data, if it has any data there, that means it has a label and we need to re-evaluate its address. We need to re-evaluate its address. But once we loaded the symbol table, we already have all of the bindings and whatnot, and we can query things, right? We can, for example, resolve a binding, right? So we can resolve a binding. By the way, I keep forgetting what this function is capable of. It only... well, it resolves... Okay, so... label or address. Cannot parse address or label. Yeah, so... that's pretty interesting. Okay, so we'll have to do that slightly differently. Reset the breakpoint label, resolve binding, so we have to call that, so I have to provide the state, then the name, since I know that the name is available, and I need to provide the binding there, right? I need to provide the binding, so it's BDB. BDB. Oh my god, the Emacs becomes too slow. It's so annoying. Fucking. Okay. So. So here is the binding, and we query for that. Alright, so let me do that. So program name. Yeah, it has to be state program name. Arena clean. Implicit declaration. Oh yeah, this is because it's arena clean. Okay. Obnoxious people thinking that I'm some sort of a no highlight freak are incoming, by the way. So is it called BDB error? How is it called, by the way? I don't remember how it's called. BDB fail. Oh my god. Okay. BDB fail. Fault or fail? Fail. Okay, so this is 0. So this is the binding, and so what's funny is that it may change its kind. It may change its kind, and do we want to actually worry about that if it changes its kind? Maybe. Sorry, don't want to do that. Too much time. Too much effort, I mean. And I'm already knocked out of my zone. Okay. BDB, is it okay or is it success or is it what? Okay, okay, sure. Why do we have also exit? That's too complicated actually. An exit for crashing, right? It's just too complicated, like it's too much information to keep, like it would be easy if it was just binary, like failed, succeeded. If you want to crash, just crash without notifying anyone. 3, 4. So if this is okay, right, so what we need to do here, we need to take the state breakpoint I, address binding value as u64, or maybe, yeah, if it's an address, I have to do it like that. So if it changed its kind, it could be kind of dangerous, I think. We could actually just test that. So essentially, if binding kind is not equal binding label, 1, 2, 3, 4, binding label, yeah, what we can do here is just print a warning. Std warning, svfmt changed its kind to s n. So what we're gonna say here is svarg. To be fair, this kind of highlighting is also not ideal because I want different highlighting on string literals and comments. So, but I don't really care about keywords or anything like that. I want like nothing style of highlighting. Do you guys know the nothing style of highlighting? Is just no highlighting except string literals and comments. So maybe I can actually grab simpc. Let me actually see. Where is simpc? Best highlight? It depends. It depends on what you're trying to do. I would like to have like a Emacs highlighting. I'm actually like okay with Emacs highlighting, but it's fucking slow. Like Nothings mode. I'm gonna call it literally Nothings mode. So, and for those who doesn't know, Nothings is the creator of STB libraries, and he has like very specific kinds of highlighting. Right, so let's create, replace simp c nothings. Right, I'm gonna just do it like that. We don't have nothings keywords. Right, so keywords. So maybe because of that I don't need to font lock keywords. And do I need a preprocessor shit? I might actually need a preprocessor shit, so I'm gonna probably keep it. Probably keep it. So I'm gonna actually remove it here. So prefix length, and where do we use it? Prefix length. Ah, it's for the indentation. Okay, so it's not needed. Cool. Previous non-empty line, not needed as well. Desired indentation, not needed as well. Indentation here also not needed. Okay, so indent line function. Oh, this is actually pretty cool. I forgot about this thing. Indent line function. All right, so here's the nothings mode. Eval buffer and nothings mode. Perfect. That's what I wanted. Because the comments and string literals, they have very significant impact on semantics to the point where they have to be distinguished. Anything else doesn't have as much of a semantical impact as string literals and comments. I think basically comments and string literals are separate languages within the current language. And that is confirmed by the fact that on the level of tokenization, string literals and comments has to be handled in a very specific way. So tokenization within string literals and comments is different from the tokenization of the whole language, which kind of confirms that they are separate languages within the language. This is actually very interesting. Think about it. So they have that much of a significant impact that they can be considered like different languages pretty much, because they require also different tokenization and different kind of parsing and so on and so forth. All right. String literals and comments are languages. Depends on the definition of language, I guess. Alright, so here's an argument changed, and so we're gonna provide this kind of thing in here. Cool. So what is it gonna be called? Oh, I need a name. Name is state. So here's the state. I think I also have a preprocessor highlighting. Yeah, I also have a preprocessor highlighting. So in this particular case, I highlight string literals, comments, and preprocessor. Let's see how it goes. Okay, so another thing. So kind bm.h binding kind as, yeah, I do have it. Perfect. So binding kind as sister, and this is going to be just a warning, right? So essentially its kind may change, and you want to be aware of that. Okay, so this is the whole adjustment. Store the pointers to the old arena. No, we don't need that. So let's put it this way. Oh shit. Recalculating, updating addresses of breakpoints on labels. Yes, that's basically what we have here. And we can remove this entire thing. Epic. So, okay, this does not require the arena shenanigans, and if I try to compile this entire stuff, it might compile, but not necessarily. Parse label or constant. So I think now what we have instead is bdb.h parse label or address. Yeah, or address, parse label or address, and let me see, is it gonna compile? Where? Okay, so this, well, yeah, now we're getting back into this thing. So I might forget actually to update the semantics of breakpoints, so I'm gonna actually put it to do. Change semantics of breakpoints. Right, so after I make this entire thing compile, I'm gonna go through the to-dos and do the fixes as necessary. Oh boy, okay, so this one doesn't really work, right? Label, because it returns you label or address. Oh shit. So parse label or address, it should be just, yeah, we don't have this mechanism, like, yeah, it's all obsolete. It's all obsolete because now we have expressions and everything. And it just doesn't really work the way the code thinks. It's just, no, it's not the way it works now. It's not the way it works. So this entire thing should be also refactored and changed and everything, so let's just... The highlighting is done in Lisp, isn't it bound to slow, unfortunately? I think the bottleneck of C mode is not even in highlighting. It feels like it's trying to do something sophisticated with indentation. And it's like constantly parses the whole file or something. Like, it's just, I looked into it and it was so weird. Like, it's just doing some really strange stuff all the time. Yeah. The explanation is that it's doing backward parsing, so there you go. Which is like, I don't need it. Like, I'm happy with just this one, and it, yeah. I don't know. Intellectual masturbation. People just want to have an intellectual masturbation. Oh boy, oh boy. I think I need to make a small break. 2 minutes around. Because I'm really getting tired. Okay, so let's make a small break and you guys have fun. Yo, what's up? Hello. Parse label or address. I think this function should be first of all called parse binding or value, right? Parse binding or value. And second of all, it should also actually accept like a word. Yes. VDBC. Parse label or address, parse binding or value. So, and this is like a word, gives you out. So yeah, so you can resolve binding and then you can parse binding or value, right? And you might as well actually, yes, so sometimes you want to know the kind of the binding that you managed to parse. Sometimes you want to know that. Maybe you don't. Because... yeah, you can maybe specify the binding, kind of the binding that you expect as an argument here. Something like BDB, like a binding kind, right? So you can specify what you expect. So, and if the kind of the binding is not that, it will fail for you, right? So, or something like that, because sometimes you want to... Yeah, let's give it a try. Let's give this kind of function a try. So this is ST. Chat, how are we doing? Is everything okay? Is everything okay? So, are you guys doing mobile development right now or something? I don't even know what you guys are doing, to be fair. It feels like you're doing mobile development. Is it fun? So address is empty, you fail. What if you fail? Okay. Alright. I'm doing UEFI development, nice. Watching the YEP clock. Distributed system, trying to set up distributed multi-head setup. Interesting. Clock development, yep. All right, so let me see. So here's that. But what if you don't care about the kind? This entire idea, this paradigm doesn't work out. The idea of just parsing as an expression was actually much better. Doesn't work out. Because I need to remove all of these checks of different kinds now. Alright, so I guess we'll have to break everything. Label of address, okay. Can it parse label or constant? So And also, why are we trying to distinguish break or not break on different kinds of things? Let's just allow breaking on anything and just forget about it. Why does it have to be like that? I think I'm spending too much time on this shit. Okay. The code makes too many wrong assumptions. It's too many wrong assumptions. Alright. So parse bindings or binding or value. And also it doesn't even parse all of the possible boson values, because it probably doesn't parse hex. And we do support hex. Yeah, I know what you... Yeah, you don't have to explain me. Yeah, I'm just thinking out loud. Yeah, this is not what I meant. Yeah, I know that you can do that. Like, it was not meant for, like, anyone. This is not what I mean. What I meant in my head, considering the current situation and future change in the bindings system, where we're not going to have a kinds of bindings and we're going to have a type system. Why do we care about this right now? Let's just not care, because later it's not going to matter. I know why you're doing that, but what I meant is, like, I have the whole context in my head, right? And I cannot just spit out the whole context while I say things. So yes, I do understand why, like, it makes perfect sense. Yes, type safety, but alright, whatever. So parse binding or value. Conflicting types. Okay. And again, you might also want to allow this thing to be avoidable, right? So it could be something like u in 64D value, u into 64 value, and then else if out equal word u64 value, right? To be fair, it could be moved somewhere here. Okay, then you have binding. We extract the binding that fails, right? And then I can set the value to the value of that thing, and then I can set the value of a word, but it could be actually something like as u64, there we go. So that's what we're doing here. Hello, Draco. Yeah, binding or value. Did we fail? Not parse address. Void variable not ignored. Oh, shit. Do you have... Okay, so that's still fine. Break address. Word. SG64. What is D? Oh, it's a deleting, I see. Okay, and this one is a word. SU64. SU64. Arena, it's a sim arena, break arena. I think we have 2 arenas in here. Yeah, so there are 2 arenas now. Okay. I'm so happy that this is a statically typed language, at least, because I have no idea how people do this kind of refactoring in JavaScript, for example. It's impossible. It's just straight up fucking impossible. Okay. So we can introduce something like define BDB breakpoints capacity, and let's say that we're gonna have 256 of them. I don't think we need too many of them. Typed languages are great. Well, JavaScript is also typed language. What kind of refactoring? Changing the signatures and definitions of the structures. Or definitions of the objects. Basically changing interfaces of the components of your software. We use an editor that does that for us. Okay, I see. Fair enough, sure. Okay. So this is what I wanted to do. Alright, so here's the thing. Adding a breakpoint. So first we check an address of the program. Since we're not doing this stuff anymore, we don't really need to do this check, because if you set a breakpointer outside of the range of the program, it will just never hit. Whatever. So that reduces that as well. So then we can talk about interesting stuff. Right, so we need to find a breakpoint by address. So we can kind of do a similar thing here, right? Where, so breakpoints, all right, something like, to be fair, BDB breakpoint, BDB find breakpoint. So you can provide either an address. I think in this case we're going to be doing just an address situation. So it's going to be instruction address. So this is going to be the instruction address, and so this is a BDB situation, and this is an address situation. And what we're essentially doing, we're just iterating through this entire stuff. So it's going to be size t, right, less than BDB breakpoints size, right, and breakpoint size. Okay. So breakpoints I, and in the breakpoints we have an address. We straight up have an address there. Cool. And here is an interesting thing. Since breakpoints will store a label, this thing should also either accept a label or not a label. So this one is going to be very interesting as well. So yeah, this one has to be like this. And if address is equal to this address, what if you have several oh well, you cannot have several breakpoints. 1, 2, 3, 4. What if the labels is already removed? Reset. Resolve binding. This one is interesting. So what if the label got removed? What do? Do we ignore that? Or do we remove the binding? Everything okay? It's kind of okay. I just have like a mild panic attack. Nothing special. Happens to me every stream. Don't worry about it. So yeah. So essentially, we still have that label. Do we remove that that breakpoint? Okay, so maybe I should put it to do here. There's so many things to consider. Okay. What do we do if the label got removed? Okay, so I just thought about it. BDB add breakpoints. Okay. So when we're trying to find this entire thing, 1, 2, 3, 4, if so we just return a pointer to BDB breakpoints I, and then we just return null. Okay, so that's what we have, and we can check for that. If I'm adding a breakpoint, if BDB find breakpoint BDB address, and I also want to be able to find by either by address or by a name. What the hell is going on? So find by breakpoint by address. By address. Okay, so if we found it, this is what we can do. Okay, it's already set. Otherwise, also assert state binding size is less than BDB binding capacity. Emacs, please autocomplete, please. Breakpoints, okay, breakpoint, not bindings, breakpoints, breakpoints capacity. Is there I'm gonna go make a cup of tea. Very quick. So we find a breakpoint, and then when we enable it, I just do state breakpoints state breakpoints size, And of course I need to enable all of that stuff now. So in the breakpoint, unit is enabled, by the way. So I suppose it could be is broken. False. Then a label has to be null, and address has to be address. Then I'm gonna just take this into sstuff and just increment this. So this is how we add the breakpoint. And of course I have to not forget to do it like this. So BDB state. Sometimes it's BDB, sometimes it's state. Okay, so my tea is ready. Mizi, thank you so much for tier 1 subscription. Thank you. Thank you so much. Deleting breakpoint. Not needed. Alright, so now we're trying to find the breakpoint. We're also trying to delete the breakpoint by address. Right, so that means we can try to do it like that then. And we always remove it by address. That's what's interesting. So it's a flawed logic, it's a flawed paradigm, it's a completely flawed paradigm. That's why we have all of these problems. Like, it's flawed completely. Should... Okay. I'm gonna make another break. 3 minutes this time. I need to pee. Alright. Have fun. already set. Okay. No such breakpoint. No such breakpoint. Okay, now we're ready to do something. So we're gonna use mem move to remove this entire thing and just decrement the size. That's how we're gonna do it. And since we don't really have that many breakpoints anyway, it's not that big of a deal to use the linear deletion, in my opinion. I just don't want to do that. I'm so tired. Okay. So, if you want to have ABCD, so we have the beginning and you have some other part, right? And you want to remove this specific thing in here. You also know the size though. So you essentially take this pointer, you take the breakpoint, right? So this is the breakpoint, this is the breakpoint. And you actually increment it by one, and essentially what you want to do, you want to move. So this is a source. This is a source, and the destination is breakpoint, and the amount of stuff you want to move is actually, so this is 3, and so the size is probably breakpoint's size minus this value. Okay, so that means it's gonna be breakpoint size. Right, so this is, we take this address and we subtract. What is he doing? What is that person in the chat asking? I don't know. Alright. Ralph, thank you so much for 13 months. Thank you, and welcome to our epic breakpoint club. So here's the breakpoints, and I need to subtract the breakpoint that was found in here. So, and initially it's going to be that, and it will give us 4, right? But we need actually like -1 in here, so that's the value that we want to have here. So, and we need to subtract that from BDB breakpoint's size. So we're subtracting this from here, right? So we're subtracting it from here, and it will give us 4, and this is what we have to subtract in here. essentially. So, and that's the size that we need to copy. That's the size we need to copy. It's the size we need to copy, and so this is a map move. To be fair, that probably means that we have to do something like -1, and this -1 is not needed anymore, essentially. That -1 is not needed anymore. So, yeah. So this is deleting the breakpoint. And it's just easier than having O of 1 mapping. O of 1 mapping just makes everything difficult, actually. But I might have actually made a mistake somewhere here. So we'll have to test that at some point. I don't know. Maybe it will work, maybe not. So let's go through the compilation and stuff. No prototype for this thing because it's set by address, right? I hate it so much. Okay, so let's just code. It's a state. Oh my god. Conversion long int. Don't quite understand. May change the sinus. So where exactly? So if I move this entire thing to long int, okay, so that means this entire stuff has to be. What is long int? I don't understand. Is it, where does it come from? Okay. Do I have to do it like, maybe I have to do this, like I know for sure that this is like that. I'm just bored. Assert, so another interesting thing here, so we have an assertion, a very important assertion in here. Less or equal, yeah, this. So by the way, if it's 1, I'm copying 0. Okay, so that makes sense, I suppose. Breakpoint. Okay. Continue. If it's broken and enabled. Okay. So let me see. Breakpoints. So we probably need to find breakpoints by address. So an address in our case is actually IP, state pm IP, if, and let's actually, and yes, literally, get them that. If BP not equal null and not broken, we continue doing the shit. So breakpoints, and when we reset and everything, so this is the correct way of doing that. This is the correct way of doing that. What else? There we go. And I changed the semantic of breakpoints, hopefully. So now they are essentially a list of breakpoints instead of a mapping from address to a breakpoint. Makes it way easier to do whatever we want to do here. Actually way easier. And it's not that hard to do 256 iterations each step, each n. It's not that hard. It's just actually not, even difficult. So maybe if we even change it to hash map, it's gonna be even faster, so it's not that big of a deal. This is more work than I would like to. Okay, this is not useful. Let's try to recompile this entire stuff. Cool. Should take information from actual print labels on breaking. Print label on breaking. Oh yeah, okay, that makes sense. I remember this one. So essentially, if BP label data, well, it depends on how exactly we were printing it. I forgot how we were printing it. So where is the hit? So this is how it was. We're gonna just use it. Like this. State labels. So now we just do BP label data, then we're trying to print that label. Label, and let me just take it here. Okay. Is it gonna recompile? Okay, to do, what do we do if, what do we don't? What do we do? What do we don't? What do we do? What do we do if the label got removed? This is a good question. So, what do we do? What do we don't? Test BDB print location. What exactly I want you to test there? I can't remember. I mean, yeah, I'm gonna actually test everything. Yeah, essentially what I'm gonna do after I'm done, like, everything, I'm going to go through all of the functionality of BDB and do the same sanity check. I'm gonna do the sanity check. So, let's continue. Is there any other to-dos? Should take information from the actual source code. BDB should be able to break on BASM expressions. What do we do if the label got removed? So maybe this is something that I want to address right now. So the label got removed. Do we remove that label as well? Probably not. But one of the things we can probably do is to just zero out its label or something. Well, first of all, we can print a warning, right? So we can print a warning. Do we also need to print a warning if the kind has changed? Nah, you know what? I'm not gonna do that. Because I'm pretty sure we'll be able to break on any points right now. Yeah, so basically I removed the functionality of checking the kind. Hello Belgian, welcome to the stream. I removed the functionality of checking the kind because it's not gonna work anymore in the future. So essentially, if the label got removed, I want to do a printf std error warning label svfmt. Okay, got removed. And let's provide the label in here. So it's gonna be binding. It's actually has to be breakpoint label svarg, right? Svarg. And then the next most important thing that I'm gonna do, I'm gonna set the label to svnull. Right, it's gonna be actually a null string. Yeah. I think that's a pretty good way of doing that. Okay, cool, it compiles. So this is my take on how it should have been implemented, in my opinion, right? So, but I think it simplifies. Oh, by the way, so here's an important thing that I forgot. When I add breakpoint, so label, we never goddamn associated it with a label. Yeah. Never associated it with a label. Okay, so this is the first iteration of refactoring. So I'm gonna just commit whatever I have. I'm not gonna push it yet, but I'm gonna commit it for sure. Yeah. Measure refactoring of everything. Okay, now, so everything is probably broken. I know that it's definitely broken because I intentionally broke some things. So the time has come to go through the functionality, and we're gonna just go through the main workflow. We're gonna go through the main workflow and just try to open a program, break on that program, and run it and see what's gonna happen. And after that, we're gonna go through each individual command and just check if they work, right? I just check if they work, and I think that will be a pretty good sanity test. So that's starting now. Okay. So I'm gonna rebuild everything from scratch, just in case. So now it's gonna be build bin and it's gonna be BDB. So build example fib bm. It loaded up, which is already great. So let's break on main. It broke, and then I'm gonna run the program. Program is already running, restart the program. Okay, so here's the first error. Here's the first mistake, I would even say. Program is already running. Let's find where it's set. Program is already running. Okay, so when that happens, when the thing is halted, is not halted. Right, so that means we forgot to put a hold somewhere. Okay, when I do a run, state, but I specifically halted it. That's what's interesting. I'm pretty sure I specifically halted the program, and I'm not quite sure what the fuck is going on. Why would it say that program is already running? Right? I think I know why would it do that. I think I know why it would do that. Essentially, because loading the program now cleans everything. Yes, loading the program now cleans everything. So BDB state init, we're gonna go there. And after we loaded the program, we're gonna actually set it here. This. I think that's a pretty good way of doing that. So yeah. Okay. Now, cool. Break main. It broke. Run the program. It hit the breakpoint, and can I step now? Push one, and it segfaulted. Nice. So it actually segfaulted. Let me see where. So we're gonna use GDB to debug a debugger. So yeah, run. Oh my god, it removed too much. All right, break main, run. Okay, so let me check. BP is broken. Okay, the assumption was already changed here. I see. So BP. So that means we have to do it like this. Okay, so if we found anything at all, and it is not broken, it is not broken. Why do we need that here then? Do we really need this thing here? What's the point of that action? What was the point of that action exactly? Wait, am I missing something? Continue, right? So, we find this breakpoint. We found it. It is not broken. It is not broken. We break it. But then, what's the point of doing this? Is it really necessary? Like, it's already false. We know that 100%. So okay, maybe something got changed over time. So all right, but in any case, I think segfault has been fixed, so it shouldn't segfault doing this kind of thing. Break main, run, boom, 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 and then continue, and yeah, there we go. So, simple sanity check has been passed. Simple sanity check, where you can just, you know, check for the program running and whatnot. Alright, so now the time has come to go through all of the commands and see if they still work. Right, just see if they still work. So let me grab this entire stuff, and so we're gonna do a very... 7, remove that. Yeah, we're gonna do it like that actually. Cool, run the program. It worked, I can tell you that. Next step also worked. Next over instruction. Okay, step instruction. This one is interesting. So yeah, we need to check if you can step over this stick. So we also check the continue works. We also kind of tested break, but we never tested break on anything like else. So this entire functionality of run, step over, continue works. So I can be sure of that. All right. Now, so I need something super simple. Maybe something like hello. All right. And I also want to take a look at the example hello bosom. Do we call any functions here? We don't call any functions in here, which is kind of meh. So let's actually create like a test PM. Maybe test bosom, and we're gonna include some of the functions, right? It's gonna be bosom examples, natives. So this is what we're including. We're also gonna include main. This is gonna halt, and then I'm gonna push 69, and then I'm gonna call dump u64, right? And then we're gonna mark this entire thing as an entry main. There we go. So something like this. Alrighty, so, and after that I think we should try to compile this entire stuff. Test bottom. Of course, you have to provide test BM, you also have to generate symbols, you have to generate all of that, and I really want to make symbols part of the file so we don't have to do that anymore. So, and then BDB test BM. What I was trying to test, I forgot. It took me too much time to do that. Step instruction. Okay, step over instruction. I'm gonna break on main, run it. And it already doesn't print the label, by the way. It already doesn't print the label. I think breaking should print the label. I think breaking should print the label, or doesn't. I think it shouldn't. Hit breakpoint. Aha, alright. Yeah. So, I know exactly why. To do. Hitting breakpoint does not print the label anymore, so I'm gonna fix that as well soon. So hit breakpoint, and let's see, we're gonna have call. So this is intentionally broken, we know that, and then can I step over this entire thing? Yeah, I stepped over it and it works perfectly. Okay, that's cool. So this functionality works like a charm, right? Except hitting the breakpoint, but hitting the breakpoint is a completely different situation. Cool. Now, so what about printing the stack? Oh my god. So build example. Forgot the name. Fib BM. Break on main, run. So let's step a couple of steps and where we are. Swap 8. Are we? Though. No, we're not. This is not swap 8. Yeah, I know what exactly happened. Okay, so this is pretty cool. We found a bug. We found a bug. And by the way, maybe I can just print the stack. The stack seems to be working, so I'm gonna mark it as a stack. And we found a bug. So I was using the smallest value of a label instead of the closest label. Okay, so that makes sense. That makes perfect sense. Location. All right. So what I was doing here is using the closest, smallest value. Well, wait. That doesn't make any sense. Okay, here's the location. I'm iterating through all of the bindings. Okay, if the current binding that I'm iterating is a label and its value less or equal than an IP, then I save it only if its value is greater than the current thing. Yes, that makes sense. That makes sense. It's actually the other way around. So, and yeah, the label is 100% above the IP, but it's the biggest one. It's the biggest one above the IP, and that makes a lot of sense. Okay, so yeah, that's cool. That's pretty cool. And let's see. So I'm gonna break on main, run, step a couple of steps. Where am I? There we go. So this is a main. And why the offset is so huge? I suppose the offset has to be smaller. Okay, we found another bug. Right. So at address and the offset, we shouldn't use location. Location is smaller. But it has to be IP minus this thing. Yeah, so IP minus. One more time. Cool. Okay, so break on main, run, step a couple of steps, and where we are, there we go. Offset is correct. Offset is fixed. Cool. So what do we have here? So I suppose we can actually have these things separately. So this is one, this is another. So put halting the machine into the BM init. Init, how is it called? Init something state init. Okay. BDB state init. State init, okay. BDB state init. Another one. Fix sec fault. Fix sec fault on hitting, on not hitting the breakpoint. So this is another one. And fix printing the location. Cool. Fix printing the location. All right. So so location is correct. Cool. Inspecting the memory now. Inspecting the memory. Quitting works. I'm pretty sure there is no problem with quitting. So the most interesting ones are inspecting memory, breaking and setting breakpoints. Yeah. So I need to pick a thing. I think I'm gonna use hello. Finally can quit BDB. Yes. Hello, BM. Okay, so can I do hello 2? All right. X hello 3 and 4, 48, 65, 67. So let me see if this is correct. Print F, something like this. XXD. 48, 65, 67. Okay, so the memory seems to be correct. The memory seems to be correct. Setting breakpoint. So I already tested setting the breakpoint. What about deleting the breakpoint? Let's find out. What's about deleting? Main, delete, and then I can run it, and it printed hello. Okay, so it ran it successfully, more or less. Okay, so all of the commands work, more or less, except I'm pretty sure I would be able to break on weird things. Yeah, I would be able to break on weird things like yeah, like constants and whatnot. Can I break on my brain just stopped. Fuck. Break on this thing. I cannot parse address or label. I didn't copy it properly for some reason. Yeah, so it can break on that. So that's another thing that we broke, but it's kind of intentional. But... So let me think how we can fix that, maybe for now at least. So in BDB we have this parse binding or value. Parse binding or value. It's not really. Parse binding or value. So usually, let's take a look at all the places where we use it. It's needed for this thing, and another one is for breaking, and another one for deleting. Okay, that's fair. That is actually fair. So one of the things we can do, as I mentioned, we can provide what bindings do we expect there. What bindings do we expect? But the interesting thing is that what if we can inspect any bindings? What if we can inspect any bindings? How are we going to handle that? So this one becomes kind of difficult. Like you can inspect only memory or a value. Right, only memory or a value. So it's just easier to split this entire thing into separate steps, so to speak, right? So try to resolve it as a binding. If it's resolvable as a binding, check the kind of the binding, right? And then use it or not use it or whatever. What if it requires more complex check than this? So that's the problem. Like, what is it? What if it requires like a very complex check? Does it require more complex check? Well, one of the things, like if we're gonna provide the kind that we expect here, so the binding kind, right? How can I say, like, use anything? Use anything as a binding, because binding kind doesn't have that. So that means I have to be able to omit that, pass it by a pointer, which makes it even stupider than that. Oh my god. So that will require like splitting all of that into several things. So we can do, yeah. I don't know. What's going to be the best way to address that? Oh, by the way, I just remembered. What is it to do? This input point does not print. Yeah. So this is should have done Brazen expressions. So I can probably address that, but I'm already tired. So. Oh, and by the way, in case of a break, we do need to know the binding if it is a binding. We do need to know the binding if it is a binding. So that requires... Okay, so I think I know what to do. So to do... inspecting memory does not check kinds of bindings of the arguments in the arguments. Okay, so parse binding or value. Okay, so breaking, adding or deleting breakpoints does not check kinds of bindings. Right, so this is the to-dos that I need to address, and I'm almost happy with the current state of the thing. And what was the thing? Oh, reset. Do you have? We haven't checked the resetting. R. Ah, I see. Okay, we haven't checked the resetting though. So we'll need to test that. Test the resetting the state of BGB. Okay. Cool. Is Marcus more back? I guess have fun. should take information from the actual. This one is gonna be the to-do. Hitting breakpoint does not print the label anymore. So this is fixable, so I'm gonna actually rename it to fix me. So this is also going to become fix me. So the difference is that fix me is something that I want to fix right now in the scope of what I'm doing. It does not check binds of kind, so this is the fix me as well. Test the resetting, so this is also fix me. So yeah, I want to just focus on things that I'm. Oh fuck, nice one. Does not print the label anymore. Test the resetting the state of BDB. Let's test the resettings of the state of BDB. So we do BDB reset, and I wonder how effective it is. Actually. So what's standard native? So we also don't initialize it. And this is something that we probably should do. BDB reset. Yeah. Essentially, this is something that I wanted to be able to do. When you're initializing the state, all right. When you're initializing the state, I'm too tired for this shit. Holy fuck. I just need to test the resetting of the state, okay. And did it actually reset it or something? I think it didn't. I think it didn't work, right? So when you do the reset, right? When you do the reset, it did reset it, but it didn't run it. It didn't run it. How does it work? Excuse me. Is this supposed to be like the actual behavior? Let me go back. Is that an actual behavior, or did I break something? I cannot tell if I broke something. It's supposed to run again. Okay, so that means it's broken. Okay. Okay, I'm gonna check if that's how it worked before my changes, just in case. Okay? I still wanna check that. Okay, so run. Okay. Seriously? The same mistake. Come on, dude. It's the second time. The second time. I spend way too much time on this review. It's just more time than I would like to, but I cannot merge this pull request in the state as it is. It is not mergeable at all, so it needs to be fixed. And also refactored, because all of that information that you're using is completely irrelevant right now. So the thing works in a different way. It needs to be refactored. Okay. So yeah, it is how it works. So it should run it again, and it didn't run it. Unless I missed something, I'm gonna rebuild everything from scratch one more time, and I'm gonna try one more time. So I'm gonna run it, program halted, one more time, and it didn't run it, and I have to continue it. Return the BDB. Okay. I swear to God, after the stream, I'm removing all of these BDB error return codes. Seriously, I'm removing all of them completely. Because they create more problems than they actually solve. Swear to God, I'm just removing all of that, ripping them off. No more BDB error. Okay, so this one, I suppose, has to go like this. Okay. And when I run it one more time, and it worked. Okay, so but I need to switch back to my branch. Right. I need to switch back to my branch. And here it is. So oh yeah, because I reset it. Okay, that makes sense. Reset. And of course I have to rewrite this entire thing. So it was something like fix me, test the resetting of the state. We didn't fully test it though, because now I want to break on main, right? I'm breaking on main, then I'm gonna run it, and yeah, and hit it again, then continue. Run it. I don't know if something happened. Okay. Break on main, run it, and it hit breakpoint, then I continue, and it halted. I run it again, restart the program, it halted. So it didn't break, it didn't properly reset on these labels and whatnot. And interestingly enough, why? So is there any way to list the breakpoints? Do we have a list of breakpoints or command for list of breakpoints? So that means this functionality was kind of broken. Did I break it? Now I'm very fucking suspicious, by the way. Now I'm very fucking suspicious. Is it me who broke it, or was it broken in the first place? Because we already had a case when it was not me who broke it, right? So now we have to go back and check. So no, we already had the case, I'm sorry. We already had the case, so I'm gonna go back And we're gonna test it again. Alright, so we're gonna confirm that yes, it worked before. Swear to fucking God. Oh shit. Sue me? No, I can just ban you from submitting pull requests. It's actually way easy. So break main. I'm gonna run it. Calm down? Are you telling me to calm down? You wanna be banned? Is that what you want? Okay, so let's continue. Well, it's broken there. Yeah. So that's how you end up blocking users. No, this is not how you end up. They're saying that their dong is calm. Okay. Alright. And to actually test that, I need to do it like that. This is the last time I'm doing that. Seriously, next time it's just I'm gonna send that pull request back to the sender. Break main. Run. Continue. Alright, run again. Okay, it works. Nice. Okay, so that means I broke it. Cool. Let's think of the ways of how I could break it. Let me see. Let's think of the ways of how we can break it. How I could break it. So I'm pretty sure. I think I kind of know how I can break it actually. BDB reset. So I'm pretty sure I did something in BDB reset. So we reinitialize everything. Wait. We load the symbols, okay. We load the symbols. Do we reset? Okay. One dong. Okay, so if we found the label, so we don't have any label. So the label stays the same. Dong is our currency. Nice. I love it. So it could be something because of BDB load sim table. Where is it? There we go. I'm just thinking, why wouldn't it break? We could implement a command that prints all of the breakpoints and their values and whatnot. BDB reset. So I'm iterating through all of that. I have a breakpoint. It has a label data. And we found a binding. And we set its label to 0. But it was initially 0 anyway. Maybe we can print them. Breakpoint. Maybe just a interesting idea. I don't know, maybe it's not going to do anything. Just a weird idea that I have. For fuck's sake, I'm fixing it right now. Where is it? Dijkstra people. I don't remember that where it says it. Yeah, it's actually, and it makes it, of course, complicated with GoTo and shit. But Nico basically told me to fuck off if I don't like GoTo, so that's exactly what I'm gonna do. All right. Focus, 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 focus. What needed to be done? Okay, break on main. Break on main. Right. Run. Continue. Continue. Program halted. Okay, cool. Run again. Run again. Run again. And it worked. That was the mistake. Wait a fucking second. That's interesting. Did I really recompile everything? Did I really recompile everything? Break main, run, continue, run, hit the breakpoint. Cool. So if I do BDB, BDB reset, and if I don't clean them up, you believe it? Break, run, continue. I don't know how, but that's important. All right. Break main, run, continue, run, continue, run, continue. Cool. So, and of course, Dijkstra to do Control D makes the us again loop go crazy. I guess you can blame Dijkstra for that. Okay. So, and interestingly enough, another thing we want to test, resetting the labels, but that's not gonna work that easily. So, hitting debug doesn't print label anymore. Yeah, I know that. Inspecting memory doesn't check. Yeah, this is that. Deleting. Test resetting. Okay, we tested that. Fix me. What's up, Jank? How are you doing? What's up? What's up? run the program after resetting this state of BDB. Another thing here is so this is the halt. Yeah. Okay. So proper fix BDB reset. And here is the thing. So these fixmes, the last fixmes are sort of interconnected with each other. Right, basically when we are adding the breakpoint, right, when we are adding the breakpoint, we need to check whether it's a label, right, we need to check whether it's a label. And if it's a label, we have to add breakpoint by label, right? We have to add it with the label, which is kind of interesting, right? We have to add it with the label. And maybe because of that, we're gonna go the following way. It's gonna be bdb.h, add the breakpoint, and we provide an instruction address. And we can provide the label, the possible label, but you can also null the label if you don't care about it, right? So let's try to do that. So this is going to be like this. Null the label is going to be string view label, and let's try to compile this entire thing. Let's just try to compile. Okay, so unused parameter label, and yeah, here when you add in a label, it has to be SV null. All right. Okay, so yeah, we can just straight up put this label here. Cool. So now, fix me. Hidden breakpoint does not print. Yeah. This doesn't matter. Okay, cool. Address. So the first thing we want to try to do, we want to try to resolve the binding. Right, so it's going to be something like oh, let me actually try the following thing. Let me do committee. It's going to be that, also that, so also that and that. Aha, cool. So the way I want to do that, resolve binding, let's return BDB binding instead of BDB error, similarly to how we find breakpoint by address. I think it's going to make it easier, so I want to go through data refactoring. All right. Make accept the label, right? Cool. And let's go ahead and do that. Resolve binding, and I'm gonna return the binding in here. And we're not gonna return it here. Let's see how it goes. Maybe it's gonna be a little bit better. So let's see. So resolve binding. This one just returns the BDB binding. By the way, Zhang, how are you doing? Is everything okay? So in here, I can return null, and then I can return a pointer. Okay, so that simplified everything. Every Monday I get a big headache. We have so many people with a headache in our community. Interesting. It's really worrying. Well, I hope you get well soon. So returning discards const qualifier. Ah, shit. Okay, so we have to remove the headache and drive and rise. Yeah, I hope so too. Oh, by the way, I had a headache too as well. Yes, it's actually quite surprising. Like right before the stream, I had like a pretty bad headache, and I haven't had it for quite some time already. So maybe something changing in the climate or something. I don't even know. Oh yeah. So now we can try to do it like this. So this is the binding. And the binding. Alright, if you have a binding, we set the value to that. Right, we set the value to that. Otherwise, we return BDB fail. Return BDB fail. Okay, so if that, you set it to that. Otherwise, we return that. Okay, cool. Another place. We had a pretty stormy weather today, actually. I just realized that. So binding, if binding works, we can do that. If it doesn't work, we can do that. Okay, seems to be working. That was a very easy refactoring. Was kind of easy, not gonna lie. Let's put it this way. I do it simplify this thing. And once we've got that, so what I want, yeah, I want to do the following thing. So where are my fix me's? BDBC, fix me, Hindenburg bucket doesn't it? Another one. Okay, here's the thing. Binding, resolve BDB, resolve binding, state, address, and that's it. Alright, if we could resolve the binding, we just add, well, first of all, we can do a very interesting thing here. If binding kind not equal binding label, we can print the wording. So put that, let's print f, std error, expected label. Wait, do I have in BM binding kind? So what does it return as? I forgot how does it... oh yeah, that's perfect. Expected label, but got this, and then I can use binding kind as sister, right? And I'm gonna just put it like that. Nothing's mod. Binding kind. So that's quite important. Alright, so 1, 2, 3, 4, and when I'm now adding the binding, right, I'm adding the binding, I'm actually adding it like this. State, and I also use the name of the binding, so it's going to be binding name, right, so this is a break address, binding value as U64, so there we go, so now we have the U thing. So breakpoints, so this is that, break address, that, resolve bindings, so this is the binding, this is that, Otherwise, if we couldn't resolve the binding, we should try to parse it as a value. Right, so we can have parse binding or value, right? And how do we do that? Oh my god. We should try to do it like this. I see. So this is the value, and we have address, and I need endpoint. So I don't remember. And pointer is just a char like this, which I put in here, and ptr. I just check if they're not equal to that. If they're not equal to that, then we can say something like std error, error. svfmt is not a number, right? And then we can use svarg address and something like this. So this is a little bit complicated, but that's exactly what we need to do here. Breakpoint set at a particular address. Parse binding label. So we don't have to do that. We don't have to do that. And we have to do this specific thing like in two places and whatnot. Here's binding. There's a potential address. And once we add, can we put this logic into the add breakpoint? Wait a second. Is it too bad? I kind of want to put it there, like, because it just kind of makes sense to put it there, like, at least for now. You know what I mean? Like, it just makes it easier. I'm sorry. Like, I do understand why you wouldn't want to do it here, but it kind of makes sense and just simplifies the current logic. Having a shed day too, kind of, maybe not that much, to be fair. It's not as shady as other days I've had, so. Alright, so, and this is the value, sv null. So, yeah, and here we even have like a checking for different kinds of things. Send hugs to chat. Yes, thank you. I'm sending my hugs to chat too. Let me hug you. So we probably don't need to break address in here, so it's not needed anymore. So, and this got fixed hopefully. So we have a situation when you have an address or don't have an address. And that brings us back to the function parse address or value. Yeah, so that kind of brings us back to that function, I suppose. Yeah, I probably will have to bring it back. Yeah, okay. Okay, so that I basically went full circle. That happens sometimes. BDB resolve binding. Initialization of binding. It has to be BDB binding. Okay, I see. What else do we have here? Seems to be compiling. Okay, seems to be compiling. Because we also need to... Yeah. Alright. So parse binding or value. Parse binding or value. And we use it like this. I'm kind of thinking all right. Oh, and another thing I want to do, BGB delete breakpoint. Okay, so here is the very important thing that I forgot. I want to introduce a function called svduplicate. So essentially it takes SV and copies it to a different arena. So it's going to be break arena. Is it break arena? Yeah, it's a break arena. It doesn't want to autocomplete. So that's basically what it is. So essentially you try to put a break and it puts a break into the break arena, indicating that it has a different lifetime. See what I mean? And so that way the breakpoint will survive resetting the symbol arena, right? So it will survive resetting the symbol arena. So we're putting it there. Furthermore, here's an interesting point. If after deleting the breakpoint, the amount of breakpoints became 0, so state breakpoints size is 0, we're cleaning up the whole break arena. Arena clean state break arena. Yes. So essentially, as we identified during development of BDB, we have two separate lifetimes. The first lifetime is the lifetime of symbol table, right? Everything related to symbol table, and the lifetime of breakpoints. So, and they are different. And the difficulty that Nico actually faced is related to these things having different lifetime. So, and when you using region-based allocators and you have different lifetimes of different objects, you put them in different arenas. So, and that's exactly what we're doing here. Everything related to symbol tables is in one arena, sim arena, and everything related to breakpoints is another arena, in a break arena. And that way it works out. And the cool bonus is that once you deleted all the labels, we know that none of the memory in the break arena is needed anymore. You can just clean the whole break arena and just don't worry about it. Does it make sense? I think it makes sense. I think it's kind of cool. I'm not sure if Nico is still here, but yeah. I wanna pee. What are you coding in C? Yeah, thank you so much. It's 16 Adrian. Alrighty, so that's basically what I do in here. But to make that possible, we need a svduplicate function. So right now we don't have a svduplicate function. Right, so let me introduce it. So it's going to be very simple. So it's going to return string view, and then it's going to accept the arena and string view sv. And then what we're going to do, string view result. Actually, I want to do the following thing. So buffer arena alloc arena sv count. So I'm just copying this thing here. Then I'm going to mem copy buffer sv data, and I'm copying this thing. Right, and then I'm just returning string view where we have a count equal to sv count, but data equal to the buffer. There we go. So essentially it takes this string view and copies it into another arena. Maybe I'm gonna call it arena svdup. Yes, this is what I'm gonna call it, arena svdup. So yeah, essentially every time you add a breakpoint, we move it to a different arena. So, and that needed to be documented. That needs to be documented, but I'm not sure how to probably do that. So, arena svdup, no previous prototype. Okay, so let's actually move that into VM because I think it's going to be very useful in VM. Okay, arena, SVM. Nice bike shading. Thank you so much for asking such question. All right, arena SV to sister. Because if you use dupe instead of duplicate, you maximizes your chances of getting hired by Google. That's why. Next question. And people unironically ask questions like that. Holy shit. It's unbelievable. Okay, so SV, arena, SV, dupe. Okay, cool. So it's a break arena. Cool. So we add the breakpoints and so on and so forth, and so we have labels. Now, ever wanted to have that long thinking beard? Beard doesn't grow on my face, unfortunately. All right, so if I run it, there we go. Now it shows it. The reason why it never showed the label is because we never actually properly set the label for the breakpoints. So where is that fix me? Hidden breakpoint doesn't print the label. There we go. It does print. So we fixed that at least. So Q. Labelness now. Yeah. Okay, so introduce this function, and in BDP. So this is gonna be like its own thing. I can actually commit everything here. All right. So set labels for breakpoints. And also add proper arena management for breakpoints. Alright, so what else do we have here? So BGB add breakpoint, delete breakpoint. Okay, so speaking of deleting breakpoint, so it's going to be fix me. Inspector memory does not check. Okay, that's another one. Deleting breakpoint doesn't check kinds of bindings. Okay, and another one, I want to actually move BDP delete breakpoint to here. Yeah, delete. Deleted breakpoint, and we can provide the address of this thing. Delete it. Okay. Let me go somewhere here. And similarly, I think I'm gonna copy paste this entire stuff, so it makes it super easy to copy paste this thing. But instead of doing this stuff, delete breakpoint. Delete breakpoint. And also add delete breakpoint. So probably want to extract this entire stuff. So let me see. Too many arguments for the lead breakpoint. Ah, okay, that makes sense. All right. So that's also another stuff. Let's see, trim, resolve binding. I guess I addressed everything I wanted to address, also inspecting memory and stuff. So speaking of some to-dos, take information about source code. BDB should be able to break on bosom expression. I want to make a small break. I need to pee. Alright, have fun. Alright, welcome back. I still have a lot of shit to do. So, fix me. Introduce BDB parse label or value again. Okay. BDB.h. Fix me. Document the usage of sim arena and break arena. So this is another thing, and I also wanna find the things. How is that called? BDB reset. BDB reset. Duplicate code in BDB reset. BDB init something. Okay, whatever. So this is the fix miss that I need to address here. Fix miss. So expect memory does not check kinds. Introduce document the usage. Okay, that's a completely different situation. Introduce BDB, inspecting memory, does not check kinds of bindings. Cool. Let's introduce that. So we have parse binding or value. And we should expect a binding of a particular type. Okay. Yeah, let's actually... what if we had like parse value though? Yeah, let's introduce parse value. Parse value. So it's going to have something like this. Parse value, and it has an input, and this is the output. So let me see. Parse binding or value. And essentially we're moving this entire thing there. Right, we're moving this entire thing there, like this. Right, so here's the value, here's the address, and I'm gonna query replace editor with input. Editor is input. And if something goes wrong, just return BDB fail. And if everything's okay, the output, if it's available of course, the output becomes that, and then we can just return BDB okay. Alright, so that's cool. That's pretty cool, and then we can use that within this entire stuff. So yeah. Wait a goddamn second. Like, this is a dangerous shit. Why are you doing it like that? Or don't you? It has to be null terminated. Do I do that in my BM? S0 to UML? No, I don't. First I convert it to sister. No. You don't do it like that. Why didn't I notice that before? Like, you have to have a null terminated. This is so dangerous. And now we need to have another arena, by the way. TMP arena. For temporary stuff. So essentially we need to have an arena that is cleaned up every iteration of a loop. BDB.h. So we also need to introduce arena TMP arena. Right, so essentially we have separate arena for breaks, for symbols, and for temporary things. So yeah, for this kind of stuff. Should be pretty convenient. So, and now, what do we do? Where is the main loop? Where is the main loop? BDB. So here's the main loop. And at the end of that loop, we essentially do arena clean state TMP arena. There we go. And here we can probably free the TMP arena. There we go. So that's the correct usage of arenas, by the way. You create like a lot of small arenas for different cases, for different lifetimes. So for the parsing, for like temporary objects like C strings, we're gonna put it into TMP. So str to ULL, right? So essentially, first thing we need to do const char sister, right? So this one could be actually called SV, and what we're essentially doing we do SV from actually to sister. SV to sister, is it not? I think it has to be SV to sister. Yeah, it's arena to SV to sister. Okay, that makes sense. Sure, I'm okay with that. So it's going to be SV, and the arena that we're going to use a temporary arena, right? TMP arena, right? Because we don't want to hold on this thing for too long, and that thing is going to be deallocated on the next iteration. So that's pretty cool, right? So here's a sister. Then I'm using sister and end pointer. And do I have an end pointer anywhere here? Maybe. So it's going to be char and ptr null or whatever. So then that, and then it returns a value, and pointer not equal to sister plus sv count, right? It's not equal to sister plus sv count, then it's fail. Otherwise, it's this. There we go. We might as well actually call it word. DDB parse word. Look how cool it is. Look how cool it is. It's just literally fire and forget. So let me actually do the following thing. So it's going to be bdb.h. So for things, for temporary things that will be cleaned up on each iteration of event loop, right? So Ramon, what's up? What's up? How are you doing? How's your headache? I hope everything's okay. What's up? What's up? For temporary things that will be cleaned up on each iteration of event loop. Okay, for labels of breakpoints. For labels of breakpoints. For any no pain today. Nice, nice. That's pretty good. And I had a headache today right before the stream, so yeah. Interesting. But to be fair, I'm really meteor sensitive, and the weather is currently changing really fast. So it was pretty calm recently, but today there was like a pretty stormy weather with a very fast wind. So maybe that actually caused my headache. But yeah, everything's fine now, which is nice. For any strings from the symbol from the sim file, let's call it sim file. So so different lifetimes, for temporary things that will be cleaned up in each iteration of event loop. I really like multiple arenas for different lifetimes. I think it just makes it so fucking cool. I wish there was also like a not annoying borrow checker that was capable of, you know, checking this kind of stuff. But I'm not sure how to implement something like this. Alright, so this is that, BDB fail, so then we do output. And so we do have parse word. Parse value, so I call it parse value. Okay. Now I want to do parse binding or word, and that binding, in my opinion, should accept also expected kind, binding kind. Cool. Binding kind. Yep. So, and now the way we're gonna do that is essentially, so this is gonna be output. BDB parse word st. So I guess we should try to parse this thing as a binding first. Oh. That's a good question. Thank you so much for asking it. Well, it's considered a programming language. Alright, so we resolve the binding. So here's the binding, and if the binding is okeg, so we can just return the value. Otherwise, and this one is actually very interesting. So if we could resolve the binding, so we can call it expected kind, expected kind. If binding kind not equal expected kind, we're gonna do something about that as well. But it makes it kind of difficult to explain what exactly going on. Like why exactly it didn't work the way I wanted to work. Okay, expected kind not equal to actual kind. Printf std error. Okay, so how do we do error? Yeah, error. Expected s, but expected, but sv is this. Okay. Expected what? Binding kind as sister. Expected kind. Right, expected kind and sv arg. Sv arg is what? Input. Binding name, and we should return fail. Alright. If we couldn't find this thing, right? If we couldn't find this thing, so binding not equal expected, kind of expected, but got. So afterwards we can try to parse this word. We can try to parse this word. Just return it like that. It's going to be st. It's going to be input. It's going to be output. Okay, cool. Return BDB, okay. And what we can say here is something like fprintf stderr is not a number. I can use a sister in here, so that's pretty cool. So that gets us halfway through. So you can now specify what kind of stuff you expect there and what not. All right, so okay, binding incompatible type. Oh shit. So binding kind. Okay, what else do we have here? Parse binding, or yeah, there's no such thing anymore. So parse binding or word, and expected binding is essentially binding binding memory, binding kind. Oh my god. For the memory, we are expecting what? Binding kind const, I think. Binding yeah, it's a binding const. Okay. Const. All right. So it's a binding const. Okay. I think so let's not do expected stuff, at least for now. So parse binding or word. So for the memory, I think it's okay. Binding or word. And because of this, all right, let's actually introduce this shit. Introduce BDB parse label or word. Parse label. Water. Parse label or word. So we do pretty much the same thing in here. If the bindings and if binding kind not equal binding label, 1, 2, 3, 4, fprintf stderr expected label, but svfmt is s. Okay, so that means I have to do svarg input and then binding kind please as sister. Binding kind. And then we return BDB fail. Return BDB fail. Cool. So parse word. And I think that should be slightly different, but yeah. So maybe we should first try to parse it as a lib and then, but I don't want to do it this way. Okay. So let's try to do it like that. If BDB fail, we're trying to parse it as a binding instead. If binding binding value, otherwise return BDB fail. Return BDB okay, and that's what I want to have here. So first I'm trying to parse it as a word. Right, I'm trying to parse it as a word. So that fails. I try to parse it as a binding, that, and then returns value. If it's not a binding not found, it's straight up fail. Otherwise the rest of that is good. Okay, similarly, I can have something like this. Have something like this, where also, when I found the binding, I check whether it's a label or not. Yes, so that's like an additional step. So yes, cool. Yeah. And now, if I try to build this entire stuff, how miserably it will fail. Let's find out. So this is not an output. Let's make it an output. Sure. Another thing. And it compiled. Perfect. So parse label and word and yeah. Introduce yeah, and this is exactly what I want to do. Expected label, but got this thing. Yeah, and essentially why I want to do that. Oh, for fuck's sake, it was pointless because it doesn't give me the label. Okay. Okay. Parse label or value. Parse label or word. It doesn't. Yeah, it doesn't give me anything. I still have to do that manually. God fucking damn it. Okay, I probably have to keep the code duplication then. I probably have to keep the code duplication. To be fair, with memory, it's kind of difficult. Spaceman doesn't check kind of bindings in arguments, so cannot parse it. Yeah, there will be duplicate here. Because you do need to have that. Expected member doesn't check kinds of bindings and arguments. Address label or constant. We don't need to check that. We're gonna just literally allow that. Do we have any other fix me's? Fix me. Document the usage of sim break arena. Okay. I guess that's it. So I did my best. Let me see if all that works out at the end. Okay. From any strings from the sim file or related to it. For labels and labels of breakpoints for temporary things that will be cleaned up on each iteration of event loop. Do we use, by the way, str to ull? Oh shit! Okay. Okay, well, at least it's two places. Like, fuck. str to ull expects null terminated stuff. It's dangerous to do it like that. Okay. I still want to have a function because I don't like this duplication. It's very dangerous duplication. But how am I gonna introduce it? Okay, one more time then. One more time. So parse label or word. So value. And also I want to provide name of the label. And name of the label could be null. Yeah, that's the way to go, I suppose. That's the way to go. And error reporting is also so inconsistent. It's just easier to keep the duplicate. It's just easier to keep the duplicate right now. Yeah, but if we keep the duplicate str to ull, check the .files comment. Okay, so here is the parse binding or actually parse word. So this is what we do here. And value. And is it called state in here or is it, yeah, and it's such inconsistency. I cannot even copy paste the function in here and just remove the type because I don't know how this specific entity is called in this specific scope, because in different scopes it's called differently because there's no consistency in naming. Okay. So the address, and then I give the value. So if, so BDB word doesn't, yeah, it doesn't print anything. BDB fail. So here's that, and I should be able to just remove this entire thing. So that's what I wanted to do. So this is not a number, expected label, but got that, and this thing is not a number. Cool. I might as well copy paste this entire thing. Yeah, might as well just remove this stuff like that. Value is not a number, expected level, got that. Okay, what do I have here? SG64. Cool. So most importantly, we don't use str to ULL anywhere else, and we do properly handle it. So we do properly handle it. Cool. So no fixed miss left. Everything seems to be okay so far. Don't see any special things that we could have missed. BGB.h, parse word, parse binding or word. So yeah, cool. So we need to do the testing yet again. Address the rest of the work. Okay, so symbolic arena, break arena, temporary arena. Yes. And okay, so let's take a look at the help. So here is the help, and let's do a proper sanity check. Okay, let's do a sanity check. Oh, we have a raid from Julius Trader. Hello raiders, how are we doing? Oh, it's a followers mod, you cannot spam in here. Yeah, followers off. There we go. Spam something, I'm sorry. We had like a raid of trolls recently, that's why I put it like a followers mod right now. So yeah, thank you for the raids, and hello everyone. We're doing a thing that is kind of difficult to explain. We're working on a virtual machine. So you can find the source code of the virtual machine here. So the idea is that we implemented a program that emulates a particular virtual machine in a sense like JVM, and it has its own bytecode that it can interpret. And we also wrote an assembly that gets translated to the bytecode of the virtual machine, so you can program that specific virtual machine. And this is not what I wanted. And the program in the assembly of that virtual machine looks like this. So yeah, so these are instructions of imaginary virtual machine. And yeah, that's what we do. So, and we also have a debugger. That's what we're working on right now. We're working on a debugger. So is it interesting for anyone? I don't know. So What are you trying to emulate? So it's completely imaginary virtual machine. So it's not like it's existing virtual machine. I just come up with my own virtual machine. It's like JVM. JVM stands for like Java Virtual Machine, but Java Virtual Machine does not exist in reality. Well, it depends on what you mean by reality, but in any case. So it's just imaginary virtual machine that you can port on different physical machines, and if you write an application for that specific virtual machine, it will work on all of the hardware where that virtual machine is implemented. So it's virtual machine in that sense. It's not like VirtualBox or VMware or anything like that. You're trying to make a VM for existing languages to use? Sort of, but I don't have any specific plans for this virtual machine. I'm just implementing it for the sake of implementing it. Are you doing jitting at this point? Not yet, but I do have plans for it. So I even started like a simple translator of the instructions of the virtual machine to assembly. Right. So I literally just take an instruction of a virtual machine and translate it to a bunch of x86-64 assembly on Linux. It works like semi-well, but once I get down to what instructions for x86-64 I need to generate for each instructions of my virtual machine, I can try to do a JIT compilation. So yeah, it uses stack-based. Yeah, it's completely stack-based. It doesn't even have any registers. So everything is done on the stack, but it does have an ability to access the memory. So alrighty, so let me finish all of that. Alright, so I was working on a debugger for that virtual machine. Now we reached my world. Enough of that Unity game dev nonsense. I don't know. I never tried Unity, primarily because it doesn't work on my machine. So that certainly makes register allocation easier. Well, yeah, I guess. So essentially, I have an instruction that can swap any frame on the stack with the top of the stack. So basically, if you have something on the stack, you can arbitrarily just pick it and swap that with the top of the stack and then back, which makes, as some of the viewers noticed in the chat, the top of the stack an implicit register. Right, so, and maybe when you're jitting, you can basically take like first like n elements on the stack, right, on the top of the stack, and basically like allocate them on the registers or something like that. Yeah, so, but we are not on that level yet. We're not at that level yet. All right, so, and yeah, I'm working on a debugger. And I made a pretty huge refactoring of the debugger for the virtual machine. So I want to go through the features of the debugger and sanity check them. Right. I'm gonna just quickly sanity check. So, oh my god, god damn it. Let me rebuild everything, and we're gonna try to test everything. So I'm gonna run the debugger, I think on a Fibonacci sequence generator. Alright, so we can break on main, run, it broke on main, and then it can step a couple of steps, and then it can continue, and it generated n Fibonacci numbers, and then it halted. So I can now quit, and everything works okay. So far I checked run program, quit, and setting a breakpoint. Right, I set the breakpoint. Cool. The control did got stuck in the machine again. Yeah, it is what it is. Is that TeamUX? Yes, it is a TeamUX. I want to learn Go for web services and Rust for CLI apps. It's better to learn just Go for web and CLI. Well, I mean, you can do web and CLI in any language you want. All right. So I also want to test the resetting of the state of the virtual machine. So let me break on the main, run this thing, continue. Then I'm going to try to run it again, say yes, and it breaks again. I can step a couple of steps and rerun it again. So it does reset the state of the virtual machine. But Web and Rust is more complicated. Software development is complicated. Welcome to the industry, buddy. It's like the whole point why we're getting paid. All right, so resetting kind of works, and N, I also tested N. Okay, so I also want to see the whole thing. Okay, so it's going to be build, bin, when do I get paid? Are you part of the industry? So it's the payment is only for industry members. I'm sorry. Bosom. So how do you use it? Okay, so we have to provide that. It's going to be test bosom test BM. Cool. So it's going to be BDB, and then I'm going to do BM. Did it work? Okay, cool. What am I testing exactly? Yeah. So I'm going to break on main, run, and I'm going to step. So here's the call. I'm stepping into the call, and can you check where I'm at? DAP. Okay, that's actually perfect. I like that. Okay, cool. And if I try to do that one more time, break on main, run. Call. Okay, so it also steps over. So the main functionality seems to be working. So I can do that. I can do that. So another one. So then I'll run. I don't know what the fuck is going on. Fibonacci, okay, BTB, Fibonacci, run everything, and I want to actually break on main and run one more time. Step a couple of steps, right, take a look at the stack. So here is the stack. So stack seems to be working quite well. Location, I also tested the location. Location seems to be working quite well. So also in the native library, we have a print memory. So I might try to print 10 elements from it, and it's filled with 2A, and I think it's asterisk. Okay, so that makes sense. So do we have anything else? Setting breakpoint actually worked. What about destroying breakpoint? Okay, so all of the basic functionality works, which is quite nice. All of the basic functionality works. So the thing I want to test, one of the major problems with resetting the state of the debugger is resetting, adjusting the labels and whatnot, adjusting the labels. And this is something that we want to check. How do you do that? All right, so we're gonna do it like this. So here's the test, test bosom, right? And I'm gonna load up this program. I'm gonna load up this program, and I'm gonna break on main. I'm gonna run. Okay, so I'm just breaking on main. I'm gonna run it, and yeah, there we go. Another thing. So I'm gonna add a bunch of bullshit instructions. 1, 2, 3. To invalidate the current label. I'm invalidating the current label, and now I need to rebuild the entire thing. I need to rebuild the entire thing. It's going to be something like build bin bosom -g test bosom test bm. Okay, so that certainly invalidated something, and if I try to run it one more time, I'm restarting it, and it broke on main yet again, and it's a label 270, which is not correct. It is not correct. Why it is not correct? So if I take a look at the symbol, main is 273, so it didn't update anything. I'm sorry if it was too loud. It didn't update anything. Okay, so that's kind of sad. The question is why it didn't update anything. So that means the functionality, the expected functionality doesn't work. The expected functionality doesn't work. Okay, so when I do reset, let me take a look. Let me take a look. Where did I make a mistake? So if we have a label, I resolve the binding for that label, and if we do have a binding for that label, I set the value of that to the binding of to the breakpoint. That should work. Okay, let's actually do something like printf. fprintf std error info label sv fmt actually has to be like that, sv fmt got reset from something like this, PRI U64 to PRI U64, and that's what we use here. And it could be something like a new line. So label, we have to use the label name. So where's the label name? Here's the label name. And then it was reset from, what is SVFMT? That's a good question. I cannot answer it right now because I'm busy writing the code. Please ask me that when I'm done with my idea that I'm trying to implement. It's a macro. Yes, it is a macro. It's similar to PRI U64. You can Google up what is PRI U64. It's similar to that, but for custom types. Alright, so let me recompile everything, and I'm gonna test. Oh my god, it doesn't even compile. It doesn't even compile. Yeah, because this thing has to be svarg. I could explain it, but I actually explained what is SVFMT so many times, and it's actually pretty involved explanation. It's pretty involved explanation. I'm sorry, I just can't explain it right now. Not enough time. Oh, this is because I was looking at the wrong. Okay, so I was looking at the wrong program. Okay, that explains it. I was testing the wrong thing. Break main, and let's run it and continue it, and everything is okay. Cool. I'm an idiot. Classic idiot. Okay, so build bin bosom -g test bosom. Please autocomplete test bm. So we rebuild this entire thing. I'm gonna run it one more time, and label main got reset from 273 to 273. That kind of makes sense, but we need to remove these things in here. Let's rebuild it one more time, and let's continue. Let's run it one more time, and it got reset from 273 to 270, which is exactly what I wanted. So that means it worked first try. I just didn't realize what happened. All right, so that's pretty cool. That's pretty cool. Okay. Well, cool. I think I fixed everything I wanted to fix. Like, fix me. I think I addressed everything that I wanted to address. Hope I didn't miss anything. Yeah. So let's see how many changes we actually made, because that's a pretty decent amount of changes. So, and if I take a look at the diff in here, that's a lot of changes actually. So, yeah. dupe. Okay, and I'm gonna push that into the Nikos repo. So I also wanna see, so we're gonna do no build test, and we're gonna wait for continuous integration because it might not work on Windows. It might not work on Windows. It's not BDB, it's BM. So reset the debugger and reload the program. So let's wait for this stuff. Okay. So once it's done, so it seems to be building on Linux Clang, which is already nice. Let's wait for the rest of the operating systems. So we tested on Linux, macOS, and Windows. Also on Windows we build it with MSVC, so it's relatively portable. The source code of the whole thing is relatively portable. Come on, Microsoft, you can do it. I believe in you. You have huge data centers with fast computers. Come on. Finally. Cool. So I'm gonna please review my changes. Thanks. Okay, so I'm gonna bring it, send it back to Nico. Because I heavily refactored his code, and let's see what he's gonna say about it. Yeah, we'll see how it goes. So the most important thing that we introduced, in my opinion, is separate arenas for different cases. Right, so we have a temporary arena, arena for breakpoints, and for symbols for different situations, for different lifetimes actually. So the smallest lifetime is temporary arena, slightly bigger is symbolic arena, right? So it basically survives a single session of the program, and the longest lifetime is actually break arena, because the labels in the breakpoints should survive between the sessions, right? They should survive between the sessions. Maybe it makes sense to actually mention that. The temporary thing that will clean up on each iteration. So basically lifetime a single iteration, lifetime is a single session, and break lifetime is like the whole thing. What is an arena? It's a region-based memory allocator. Region-based memory allocator is this thing. So in some terminologies they are called arenas. They're called arenas. So yeah, so we can read more about them here, and they're quite cool for separating lifetimes of different objects, and you basically allocate memory into that arena, right? And you can quickly just clean up everything within arena just in one sweep, so which makes it super convenient. All right, so today was a pretty long stream, but unfortunately it is time for me to go, boys and girls. Thank you everyone who's watching me now, really appreciate it. Thank you especially Nico for not being afraid to submit pull requests to me, and for standing up all of my unconstructive criticism about his code. So he's a great developer actually. I'm a really bad communicator in open source project, but he's a great developer. Thank you so much for the pull requests, and I'm really sorry. So yeah. Yeah, thank you for watching. I see you all tomorrow. Tomorrow, according to the schedule, we're gonna continue developing this project. Hopefully we'll get a feedback from Nico and we'll try to fix it or address it or do something with it. Check out our schedule for more information on different projects we're working. We're working on different projects, sometimes, quite often, I don't know. Check out our VODs channel where we upload the recordings of our streams. This stream is going to be there as well, but a little bit later. And check out our Discord server for offline discussion with the community. So yeah, and let's maybe rate somebody, I don't know. Is anyone streaming right now? Anything interesting? Cache, we raided Cache recently. I don't really like to rate the same people over and over again, so let's actually rate somebody else. 1 lives left. Is he streaming right now? His icon doesn't make it easier for me to understand if he's streaming. Okay, he's streaming. Twitch. Why are you so bad? Holy shit. Okay, 1 line left. Okay, so let's raid 1 lives left. So it's 1 lives left. Okay, so it's another GI streamer. So yeah, guys, ready for the raid, boys and girls? Guys, ready for the raid? And yeah, I see you all tomorrow. Love you all.